All right. So this is what we'll do here is we're going to do a 3 hours. We're going to probably do 1 hour, then a break, 1 hour, then a break, and then probably half of an hour at the end. So maybe give a little bit of time for Q&A and questions. So let me share my screen and we'll get started here. Okay. So data literacy fundamentals for veterans. Hopefully you all have all we need today. So that, you know, the email that I sent, wow, so many software platforms to download and install. You know, the good news is they're all free, I guess, except for Excel. Everything else that we're doing and using over the course of the next 4 sessions together involves free software. One of the links is a software that has a trial. Everything else is, I think, free pretty much indefinitely, which is really cool. How many amazing software tools there are out there nowadays. I'm trying to compare that to when I was a kid growing up, and I just, you know, there's so many more things you can do now with data, and we're going to do a lot. So my goal here, my whole theory. Okay, so not to get wax too philosophical, but look, I've been at a company, an amazing tool company, teaching people all over the world how to use that software product. We're going to talk about that one. It's really amazing. Tableau is one of the best data working tools that's ever been made. But you know, you can't be, my theory is you cannot become data literate with only one tool. And so, you know, I left Tableau in order to start a business to help people gain a general understanding of data, spreadsheets, databases, SQL, Tableau, you know, R and stats. Those are all things that are really helpful to be able to understand. And so for me, you know, while I was running the Tableau public platform at Tableau, I also started doing University of Washington classes that I was instructing. And I kind of just got into it. I really fell in love with the experience of teaching people, you know, having them get excited about data, many of them for the first time. And so that's sort of why I said, you know, I'm just going to do this full time. It's just too fun. And so that's what we're going to do. Okay, now I'm going to go ahead here and we're going to project, and let's see if I can show this whole full screen. Here we go. Okay, so I thought to myself, what better way, you know, than to get started here than to run a program that would kind of speak to, you know, how to do this, get feedback from a group of people. And at the time, it was International Volunteer Day, and I thought, well, I like to volunteer my time. I'd like to be able to give some time back. And so, you know, at that time, you know, I'm from Thousand Oaks, California. And so, you know, you all heard about that. And so the thought occurred to me, you know, that you just can't go a few days without hearing, you know, that we need to do a better job taking care of people that have been in the armed forces. And so I thought this is one way to do that, to share some things that I know. And so that's why I came up with this fun little program. You can see I got some dog tags in there with some goofy quotes. We've met the enemy and it's not data. I don't know if anybody actually has a dog tag like that. I know I don't, but it is on the slide and I was getting creative there. A little bit about me. Again, so my name is Ben Jones. I founded this company. It's been incorporated for about a better part of a year, but really just getting started now. So I did a mechanical engineering program at UCLA that I wrapped up back in 2000. And then I finished my MBA at a little school in Thousand Oaks called the California Lutheran University back in 2011. So that's my education. I also spent time in Medtronic, a medical device company, doing the whole Lean Sigma, Six Sigma training circuit. So I trained people how to use statistics to improve business processes, manufacturing, you know, also just not just manufacturing, but also billing, collections, customer service, and found out that you can apply data to all of these kinds of endeavors in a company with some pretty amazing results. And so that is sort of what got me into this. And then that's what got me really excited about data. So I downloaded Tableau Public one day just on a recommendation from someone who had done some amazing work I saw. And that got me going, you know, and I started using Tableau Public and kind of got lucky and won some contests and ended up getting hired by Tableau. Moved on up here with my family back in 2013, and then got a chance to write the book, Communicating Data with Tableau, which is an O'Reilly book that was published back in 2014. And started, also had been doing a lot of blogging and things like that. Something a little bit about me personally, I like hiking and backpacking. I was never really much of an outdoors type before I moved up here. I did a few things, not many, just a couple. But since I've been up here, I've just been going crazy trying to find as many trails as I possibly can. You know, it's kind of a good way to balance the digital side of the amount of hours you spend in a day in front of a computer, working with data like I'm about to talk to you about. Hey, this is a chance for me to get out there and just experience nature, be out there in the elements. You know, it sounds corny, but it's totally true. It's a really refreshing experience for me to be out there on the trails and the coasts. And I love, reading. Gosh, I got too many books around here. I like sports, although now that I'm starting this business, I don't have a whole lot of time to watch. I think the Seahawks won yesterday. And I like soccer. I like volleyball, so I play a lot. I'm working on my second book right now called Avoiding Data Pitfalls, which that's basically a catalog of all the things not to do when you're working with data, because I know I've done many of those things over my time. And so I'm trying to write a book that I was kind of like, I wish someone wrote a book for me, 5 or 10 years ago that told me, not the stupid things I shouldn't do. And so that's what the second book is all about, which will be a fun one. Cool. Okay. So the course agenda here, 4 sessions. This first one really going into like the basic elements. So this will be the most lecture of all of the 4 by far. The most, more than anything, I'm going to try to get into more demos and hands-on. And then we're going to get into preparing data for analysis. Then we're going to talk about exploring data for analysis. And then lastly, making multifaceted views, which we call dashboards. Essentially, it's a fancy word for times where you have charts next to each other. That's really what that means. They're side by side and above or below, multifaceted, as opposed to a single view. But then also, so that's taking individual views and putting them next to each other on a single view, right? A single visual. But sometimes what we want to do is sequence them together in what we call a data story. In other words, that's me telling you, hey, I'm going to show you something first, and then I'm going to tell you how something changed, and then I'm going to give you a final conclusion. Almost like I'm telling you a story. There's a narrative arc to the presentation that I show you. So my goal is that you're going to be able to do all of these things, and I literally don't know a program that exists that walks you through all of this. I don't think it does. I mean, you'd have to go pay $50,000 at Berkeley or something to get all of these things. And you get more than that there too, like data science and more advanced algorithms that we don't have time to cover in what I'm considering like a level 1, course here. And this is really targeted at people who are coming to data for the first time. My goal is to really help everybody get to the place where they're participating in a data dialogue in the companies and the communities, you name it. So that's the goal of this first one. It's kind of like that level 1 program. Hey, I kind of get a sense of all of these tools and I know how they work together. I understand it from a process point of view, and that's my goal for you. Now, we're going to be doing this over 4 sessions, as you know. Today, the 11th, and then Thursday, the 13th. Also next week, same 2 days, the 18th Tuesday and then the 20th Thursday. And that's going to be how we go right through it, And so I would love to hear your feedback every step of the way. And so feel free to send me your comments and thoughts to bjones@dataliteracy.com as we go along. And even live during, you guys are great. You're already chiming in and unmuting. You notice that you can mute and you can unmute. So anytime you want to chime in, interrupt me, answer a question that I ask, just feel free to unmute, and there's no need to wait or anything. Just chime right in, and I'll catch you, stop and listen, and we'll learn together. Okay. Now, this first class, the basic elements of data. What's this about? Well, we got 3 hours together here. And what I want to do is kind of go through, hey, we're right on track. Oh my gosh, look at that. Welcome and course introduction, 15 minutes. Boom. Hey, it's 3:17. In spite of all of that, we're actually pretty much only a couple minutes behind. So I wanted to just kind of introduce myself and kind of, again, give you an overview of what you can expect in the course of the next 4 sessions together. But what we're going to do today is, in more detail, is I'm going to talk about what it means to be data literate. It's a phrase, it's sort of a metaphor, because literacy just means you can literally read a language and understand it. But what does that mean as it applies to data? And so I want to talk about what I feel, defines someone who is highly data literate. Okay. And that might help you kind of get a perspective around, what I hope to do with that, and why I'm doing that first out of the gate, is because I want to calibrate, what I hope to help you walk away with, as well as maybe what your expectations were coming in around, what does it mean to develop data literacy? And let's have a conversation about that too. This is not like some written in stone 17 traits that I got handed to from on high, right? This is my starting point. And I've been reviewing this with some really, I would say, world-class experts in the field. people like Alberto Cairo of University of Miami, Cheryl Phillips of Stanford, Tamara Munzner of the University of British Columbia. These are people who write, all these books that are sitting down here next to my desk that I read, that I use in my classes. They happen to be friends of mine. I'm real lucky because of Tableau to have been given the chance to connect with a lot of these individuals. So I ran it by them. I have been running it by them, kind of getting feedback live, really, to be honest. And I'm also working on an ebook with a designer to take this and just really, I want to get it out there. I want people to really have a good feeling about what it means to be data literate. And it isn't just a list of skills. Okay, that's the core thing I want to get across in that section. All right, so then, that's the first section, right? Next, we're going to go on to a process I'm going to walk you through. In my mind, having gone through the Lean Sigma program and trained people all over the world on that, I really feel like it helps to learn something as adults as we are, if we're given a framework. And oftentimes, a framework you can use is a process, a way to think about doing things in an order that helps you know where things go. So as we talk about knowledge and skills, you'll be able to connect it to a broader process, okay? Now, I will start off by saying this is not a rigid process. And exploring data can be one of the messiest, craziest things you'll do. And it's very iterative and loops back and forth. And so that's okay though. Actually, I still think it's a process. It's just we meander in it. In some ways, we have to embrace that. And if we try to be too rigid and march through step 1, step 2, step 3, we're not going to end up where we want to end up, which is obtaining true knowledge about the world. Okay. I'm going to spend a little bit of time. I'm not going to wax too philosophical here, but I'm a big believer that we have to have a good foundation in what we call epistemology, or the science or the philosophy of how to think and make opinions, beliefs, and things like that. Frankly, there's a lot of things we can do with data that'll get ourselves pretty wrapped around the axle, and we'll mislead ourselves if we're not careful. So I'm going to spend just a few minutes on that. We may actually be ahead of the game on that one, but a couple little pitfalls to watch out for that are going into the first chapter of my next book. Okay, and then on over there, basic elements of data. So this is so important. Think about it like this. If you're a writer, okay, and you're writing poetry or fiction, you care about what? You care about words, you care about letters. These are your foundational building blocks of your craft, of the things you use to combine together as the raw material that you use, right? So I want you to think about data along certain lines to be able to kind of understand what the different kinds of data are that exist. And that's going to seem really textbooky, okay, academic-y, but it's not. It's so important to kind of know what is the difference, for example, between, a categorical value variable and an ordinal one. What does that even mean? How do we understand that? And so what? So I know the name of something, right? No, it's actually really important. It's going to totally drive how we create data visualizations and how we analyze data. So the basic elements of data, really important section there. And we're going to ground ourselves in knowing, what are the E's, I's, O's, right? The vowels, the consonants in the world of data, okay? And then we got to get hands-on. I can't sit here and talk to you the whole time, right? We want to start to kind of roll up the sleeves, use Excel to try to have some fun with a data set here that I picked out that, maybe we're interested in. Maybe some are, some aren't. You'll see what it is, and we'll get to that. But the idea there is I'm going to teach you some real skills. Some of you deal with Excel day in and day out like me. And so this will be a little bit of a review for you. Others, this is this program that you have felt you kind of need to dive into at some point. So I'm going to assume we're starting there, from a point of view of a beginner. Let me tell you this about Excel. I think it is I'm not even exaggerating. I think it's the single most valuable piece of software ever written in the history of software on this planet. It is a tool that is used by every industry, every discipline, every background to do all kinds of analysis. You'd be shocked at how much of our financial world is built on Excel spreadsheets and really smart people building amazing models in them. And so we're not going to go into the advanced functions, but we sure are going to be able to dive into it and do some cool things, okay? Including pivot tables, which Maybe you've heard of a pivot table. It's a way to change the structure of your data. And we'll talk about structure and what that means. Okay. And I got a little assignment for you. Obviously, this is a free course, so you don't have to finish it. But I will tell you this. And this is coming out of 3 years of experience for me, teaching people data. If you take the things we're going to do today and you do them again on a data set of your own that you care about, that's data you found about something in your life, in your world, and you redo the same steps, you will remember it so much better than if you just use data sets I give you. And the reason is because it's yours, and you make it yours by taking that data that is in your realm, something you find. Maybe it's even a data set you create. Maybe it's one you find online. Maybe it's one you already have and you've been meaning to do some work with. But in any case, it's not mine. I'm not giving it to you. It's not a training example. It's not a workshop thing that you have no kind of connection to, right? So data is something that, in my mind, the first step is to see it as a lens to understand our world. It's not some abstract thing, oh, I got to learn Excel now. Like, what's Excel? Why do I care about Excel, right? Well, no, maybe you want to understand something about your steps with your Fitbit. So you care about that, right? Potentially. So in other words, don't think about it as the tool so much as a way to get at your world, a way to really kind of become more fluent in what's happening in your world. Okay. So again, I challenge you, I'll do that, to spend some time and try these things again on something you care about. I'll talk about where you can find data. When I teach this class at University of Washington, or slightly different, I do the same thing with those students. And I tell you, the first 3 weeks, they hate me for this. They come in and they say, Ben, I spent 3 hours trying to find a data set. And sometimes they email me in the middle of the week. They're like, help, I can't find a data set. Can you please give me one? And I said, okay, I'll give you one this time, but next time, no. And so by the end of it, though, it's funny. They come back to me and they say, hey, I'm kind of glad you were such a jerk back then and made me go find my own data, because now I got 10 weeks worth of amazing examples and projects, and I'm building a portfolio now, and I've remembered all of it, as opposed to your assignment is to take this spreadsheet. Like, okay, I can do that. I just don't think it's going to be meaningful to you. That's our overview, and we got to get into that. So any questions about what we're going to do in the next 3 hours, or comments about this agenda? Everybody thumbs up, everybody good? Yeah, okay, cool. Let's go. So what are these 7 basic traits of data literacy all about? So I asked myself when I'm starting this business, what does it mean to be data literate? And I came up with, I said, well, why don't I instead, my starting point was to say, oh, you got to know R, you got to know Excel, you got to know Tableau. And then I stopped and I was like, is that all it is? Just a list of tools, and you have to know what buttons to push and everything? Like, is that what a data literate person is? No, I don't think so at all. It goes way beyond any list of skills. Now we need to know the tools. So don't get me wrong. I'm not trying to say tools are not important. I'm just saying it's not about the tools. The tools are a means to an end. Okay. So I said, well, hey, why don't I think about it along 4 lines? Knowledge, skills, attitude, behaviors. Knowledge, skills, attitude, behaviors. Those describe people, right? I have things I know. That's my knowledge. I have skills. Those are actions I can carry out, tasks I can do. Okay. I have attitudes, ways I think or feel about things, my points of view and my opinions. And then behaviors. Those are like my habits, the way you would see me interacting in an environment. And so those are like my kinds of behaviors that describe me. So here they are, like in one little snapshot here. 17 basic traits of data literacy. There we go. 17 icons, one for each of them. And we'll go into those one by one. All right. So the first grouping is knowledge. And I said to myself, hey, what does someone need to know to be data literate? And you could probably break this out into many more, and each one of these could flow into its own little set of like an outline. But at the end of the day, if someone's data literate, I'm saying I'm going to hire someone, or I want someone to talk with me about data. They've got to sort of know what the different elements and different forms of data are, right? They've got to be able to differentiate between different types of data. Also, whether this is a quantitative or a qualitative attribute or variable that we're talking about. And for them to be able to say, like, yeah, I get that. I know what the differences are there. That's important. So basic elements of data, those are things they know. Number two, they need to be familiar with ways that data is collected, structured, and stored. So how do you take these observations or records about your environment and put them somewhere? Where do they go? How do they get there? When they get there, like how are they brought together into something more than individual facts? There's different ways to combine them together. So they need to be able to understand that. We're going to talk about a few different ways here. We're going to talk about, spreadsheets and databases and tables. We're going to talk about structuring, pivoting, going from a long and tall series of records to a summary table, and it's wider. Okay, so we'll talk about that difference and what that means. All right, and then number three. So this is a broad one, and this really has many, many tentacles, but they need to grasp the fundamental principles of analysis and statistics and when they apply. So how do you analyze data? When is it important for you to understand, correlation versus causation? What's the meaning of comparing two different distributions? How do I understand the shape of a single distribution? Those are different ways we analyze data. It's a very broad category. But knowing the basics of analysis is critical. And we're going to do a lot of analysis over the course of the next 4 sessions together. I don't think we can cover it, the entire corpus there of data analysis is a very broad field. And so, it's different components of analysis and statistics apply differently based on your environment and your situation. And so I might be an expert in a few different types and completely novice in others. And that other person over there might have the flip-flop set of knowledge that I have, okay? And then last thing, it's a really important piece of working with data is visualizing it. And this is one thing that I think Tableau is the reason why it has been such a runaway success, is because it makes it very easy for you to visualize your data. And you can, it's such a shortcut for a human being to use their visual cortex to be able to spot patterns and trends and outliers immediately, almost what we call pre-attentively. So we're going to cover that, basic concepts of visual cognition, ways that human beings grasp and understand the data that's shown visually. Okay, so that's knowledge. Those are the 4 things, the groups of things that we need to know to be data literate. Skills. So this is the only category with 5. The other have 4. This one, I ended up with an extra skill in there. All right, so 5, reading and understanding visual displays of data created by others. This is so important, especially, by the way, the higher up you go in an organization chart. Guess what? You have to consume data all the time. And it was, of course, almost always made by somebody else because you employ, as an executive, teams of analysts who are creating dashboards for you. And so this is a big part of what they do day in and day out. And the rest of us the same. You can't pop open a news site without seeing, a data visualization these days, a timeline, a bar chart, a map, right? How do I read that? How do I understand what someone else made in visual form and interpret that? How do I know what questions to ask? That's a skill. It's a skill to be able to dive into a visual display of data that someone else has made and have an intelligent conversation with them according to what they've created. Okay. 6, cleaning dirty data. Oh my gosh, you guys, there's no such thing these days as a clean data set. I don't know if there ever was. Data is always dirty. It's got problems with it. It's got errors. It's got glitches. It's got formatting issues. Every single data set I ever touch has something wrong with it. Okay, so it's really important for us to be able to know how to go in and make modifications to that, to spot where the issues are. Okay, visualization, by the way, as an aside, is a way to find issues in data. Not the only way, but it is one way. Part of that is exploring the contours of the data, as we're going to talk about, being able to know the minimum, the maximum, the range, going around, walking around the outside of your data set and seeing all the weird intricacies and components everywhere. Cleaning, and then when you see it, okay, so hey, you type in something. One of my favorite data sets, and maybe I'll show you guys in a little while, is there's this hilarious data set. You know what it is? It's, have you ever had your car towed? Too many times for me. In fact, it happened not too long ago. I got in a car accident, like right over here by my house. And it was in the rain. It's raining right now. I'm in Seattle. You know that. So it was raining. It was nighttime. It was dark. I was standing out there. And the tow truck guy came. He's filling out the form. The policeman came. We're looking at each other. He's trying to figure out which piece of paper goes to me, which goes to the policeman. I was like, don't you guys do this all the time? They didn't know. And it's raining. We're all trying to stay dry. And we're signing stuff, whatever. And then next thing I know, whatever, it was all over. But there was a data set I found about that. What it was towing yard data in Baltimore. You will never believe how many funny ways there were to spell Ford. Four letters, Ford, F-O-R-D, right? But it was typed in manually by people at the tow yard, and they got the forms from the people in the tow truck, and they typed it all in. Unbelievable. It's hilarious. In fact, let me see if I have that open real quick. I'll just show you, just for kicks and grins. Let me see if I can find it here. Do I have it? Yeah. All right, check this out. This is a complete tangent, but I gotta show this to you. It's too funny. And it's not just Ford. It's, by the way, okay, here we go. Ford, let me move it over here. Check it out. Ford, where are you? Hey, that should be. Oh, come on. See, two screens. Two screens is supposed to be easy, except for when things don't go from one screen to another. Should be right there. Oh, I know why. I have to escape out of the full screen here. Oh, here we go. View. Escape. Okay. You know what? I'll have to show you later. That's bizarre. It just won't move over. It's right there. It just won't move. Anyway, lots of funny ways. Funny ways that people thought to try to spell Ford. Oh, there you go. Can you see that? There we go. Can you see me? Can you see it now? Ford. Okay, how about this one? Peterbilt, Peter Belt, Peter Butt, and Pete. Tow yard. Love it, right? Mitsubishi and Mitsubishi with a T at the end. And there's one called Burnt Car, which I thought was kind of funny. Maybe it's not, I don't know, but it was interesting. Those are the things that you'll find in the data set from the Baltimore tow yard, which is dirty data, right? Of course it is. Why wouldn't it be? Why would it be clean? Why would it? That would just be, that wouldn't be, that's not possible. Dirty data. Okay, so number 7, let's keep moving. Exploring data sets and identifying relevant facts, patterns, and trends. You've got to be able to dive into a data set and answer questions and find things. We'll do a little bit of that today. Number 8, creating clear visual displays of data to reveal insights to others. So we talked about in the knowledge, section, that you have awareness of the kinds of rules of visual display. Well, that's not enough to just know that. We also need to, in order to be, it's sort of like, to be literate, you need to not just read, but you need to be able to write. No? It's a little bit of both, right? It's you to read and write. So, well, this one is about creating. So you know what works well and what works not so well, as in the world of data visualization, and you know how to actually use software and tools to be able, and it could be very primitive and simple, by the way. There's a whole movement right now of hand-drawn data visualizations. If you're ever interested in it, there's a couple books on that are really cool. Here, I'll just show them to you. I got them right here by my desk. It's by a friend of mine. Her name is Georgia Lupi, and actually her friend Stephanie Posavec, which I've never met. It's called Dear Data. So it doesn't have to be fancy. These two ladies wrote postcards to each other back and forth across the Atlantic every week about something interesting about their life, right? They did it by hand on a postcard. There you go. And then they wrote a book here called Observe, Collect, Draw, which is where they basically say, this is like the same thing but empty, right? You can do it. Right? So it kind of walks you through, and then you can go draw it. It's awesome. It's given the human side of data. You don't have to use some fancy programming language or Tableau or anything else to be able to communicate data. So important. But whether it's by software or by hand or by carrier pigeon, I don't know. You have to, you have to be able to create visual displays of data that says to someone else, "Oh, wow, check that out. How interesting. I can see what's going on there." And then last skill here, communicating effectively using data and information gleaned from it. So it isn't just enough to make a lonely visual chart, dashboard. That is a piece, that's an artifact out of context. And so, what's important then is for you to be able to say, I'm going to walk you through, talking you through, describing, writing long form content in an article or a report that says, okay, yes, these are the charts and graphs, and here's the so what that goes along with it. Here's my interpretation of it. Here's what I want you to understand based on what I've seen. And that's the communication piece. So important, which, by the way, leads back to a lot of other questions. We'll get to that in a minute. Those are the skills. I think they're the only skills. I really do. I think to be a data engineer, you need to know a whole lot of other skills of setting up and storing and making warehouses and such. I don't think that that's really covered here. Okay. Attitudes. So you might say, someone who's literate has certain attitudes. That's kind of weird. I think it's very important, actually. 10, believes that data is a language that anyone can learn to read and speak. That's actually an important piece of literacy, because why would you be data literate if only to be able to communicate with other people, right? That's the point. What else is the point of writing thoughts in language of any kind? Well, it's to be able to connect with another human mind. Well, if you don't think that the other human mind across the table from you is capable of figuring it out, then why bother? And I would say that to me is an indication of someone who doesn't really fundamentally get it, that this is an practice of communicating from mind to mind. So that's important, to be able to have faith that the other person can figure it out, can get there. Okay, 10. 11, feels confident using data as a resource to answer questions and identify new ones. Confidence is big. There's so many people. We go to school as kids growing up. We were told many different things about what our capabilities were. And that affects our confidence in lots of ways of life. And I think that many of us need to work hard to overcome messages that were given to us early on about what we're good at and not good at. But I've seen people get over their feelings of lack of confidence in terms of working with data. And so to me, I would look to someone and saying, they feel like they have what it takes to be able to use data. It's a resource for them. It's a valuable resource for them, and they use it and they dive into it and they feel like it's something worth doing, that they're capable of. All right. 12 is wary of common pitfalls. I write a whole book about this, but data is not a panacea, and there's so many ways you can misuse it. There's so many ways you can be misled by what you see in the data that you interact with. And so a very, kind of important trait for someone who's data literate is they watch out for those kinds of things. And they are on the lookout for normal, very common and super typical pitfalls that I fall into, people fall into, experts fall into all the time. I mean it all the time. It's literally, you're going to kind of go on a journey and you're going to trip. Like you really almost are never not going to trip. So you almost have to accept that. It's nothing to be ashamed of. It's just being able to notice it when it happens and being able to correct for it. Pitfalls. Okay. 13, ethics. Oh my gosh. Is there anything that we've seen in the news in the last couple of years that's more important than that? Companies using data for unethical things, purposes, violations of privacy, you can't not see it. This is such an important component that if you're using data to harm people, I would go so far as to say that's not data literate, because you don't understand the reason why you would want to use the language in the first place. Ethics is big. Ethics is big in the world of data. And I actually had an entire section in here, and I realized I wasn't going to have time for it. So I'll send you some links to check out. In fact, I'll just drop it into the chat. Also, that will give you the ability to see how that works. But I got really lucky and had a chance to co-author a paper with an amazing group of people. And it's published over here at datapractices.org. So I'll just drop this in the chat. Let's see if you guys can see where this goes. This is our first time using chat. To everyone, paste. There you go. If you look at the little chat there, you should see a link to datapractices.org/manifesto. Put that as a little bookmark, or come back to it, leave it open on your browser, go back and take a look at that. This is just really saying, hey, what are we going to do as data teams to make sure that we're not using data for unethical reasons? And kind of how do we commit to that? How do we counter the very powerful commercial forces in our companies and all around us that are going to ask us to do things that, if we were on the consumer side of it, we wouldn't want that. That's not how we'd want the company to treat us. So we need a kind of a code of ethics to combat that. Okay. So ethics. that to me is like a component of literacy. Last but not least, behaviors. Okay, so number 14, seeks out and creates data as a means of gathering information. So this is the person who's data literate that says, you know, hey, I'm going to go make a data set if it doesn't exist, or, you know, I'm going to go find that data. I'm going to go look for it and I'll find it. It's out there and I'm going to find it. And so they are dedicated to that. And they see this as one of many, not the only, one of many ways to capture information about their world. By the way, we're taking in information all the time, our senses, you know, our own minds and you know, consciousness tell us things about the world we live in. And that's all data in a broad sense or definition. But we're talking about a more specific definition here of spreadsheets and databases, ones and zeros and computers. But at the end of the day, it's just a type and we can't shy away from it. So someone who's data literate makes that happen. It reminds me of, if everybody knows the story of Florence Nightingale, this is going back a couple hundred years. In fact, I think if you get a nursing degree, an RN, they make you take the Nightingale Pledge as part of the finishing of your program. I could be wrong about that. I do believe I've read that. But she's also a fabulous data visualizer. Okay, and so one thing she did, she was working in these, she was an incredibly smart woman, but and decided not to get married. Let's just leave that alone. She worked in, she was fascinated with mathematics and statistics, which is a little bit ahead of her time. But her father taught her all about it. And she had a mentor, she had a teacher who taught her. And then so she also went to these British Army field hospitals during the Crimean War. I think the hospitals were somewhere in the region of Turkey. And then she was there, you know, doing nursing, taking care of soldiers who were wounded and injured. And she started to notice, you know, that the mortality was too high. And so this was, I'm talking about the 1800s. There was no computers or files or Excel or anything. I mean, you know, if you collected data, you collected data by hand in tables. And so she did. So she started walking around month in and month out, counting the number of people who died in those hospitals and why they died. And so, you know, she's a nurse. You might say, like, it's not her job. She should take care of the soldiers. No, she saw, and this is what I mean. She was highly data literate. She saw it as her job to capture the data. What was happening, because she felt there was a problem and nobody else was collecting it. So she did. These were these remote field hospitals. Okay. No sanitation. We're talking about just like really squalid conditions, people dying left and right. And what she was noticing, which she wanted to get attention to, was that, if I look at Florence Nightingale here, sorry, 1 second. She was noticing that soldiers were dying because of conditions, not because of wounds. Coxcomb plot. Okay, so let me show you what she created. And she went back to the Queen at the time, Queen Victoria, and you can see here what she created. These are these Coxcomb plots she made, which show, if you take a look at it and look real carefully, so I can zoom in on this. So she was noticing that this is this wheel right here, okay? She was noticing that, so this is July right here, this little wedge, and the wedge is how many people die. How big the wedge is tells you how many soldiers were dying. And then it goes around, sorry, it's kind of small. Let me see, kind of zoom in. Hey, there we go. Does that zoom in for you or no?
Yeah.
Oh, good, okay. I never know if it zoomed. So July, August, September, see that? So what do you see? So first of all, the red ones are soldiers that died because of in battle, okay, and they came back to the hospital. The gray ones were soldiers who died of their wounds later on. The blue, kind of grayish blue wedge, are because they died of communicable diseases. They got sick in the hospital while they happened to be in the hospital, died of something unrelated to their wound or injury. Okay, so what do you notice, right? First of all, the vast majority of the casualties in the hospitals were from communicable diseases. Number two, it got worse in the winter, and that's because they were huddled together in these poor conditions. Okay, and so she took this all the way back to England. She got an audience with the Queen of England at the time, Queen Victoria, and it was 1855, and she said, "This is a problem. We need help." And so they agreed, and they went back and they sent sort of a sanitation commission into these field hospitals, and were able to clean things up. And you see the improvement over here on the left, right? So, but the point is, and how it relates to our traits, is that she took it upon herself to collect the data. She didn't wait for somebody else to do it. You know what I mean? She didn't she did it herself. And so her literacy was showing there because she was actually seeking out and creating data. 14. 15, identifying areas of opportunity for improvement in the data and associated analysis. So, you know, that person's the person's out there saying, hey, I think, you know, we can do even better, actually. There's an issue with this database. There's an issue with the way we're doing things or this kind of analysis. And so they're a proactive person that brings to the surface in a tactful way the kinds of things that we can do to make the situation better. There's always opportunities to improve so many things about data and the way we use it. And that, you know, data literate person in our company, in our organization, and even in our societies, our communities, just like Florence, she should start from scratch with nothing there, right? But the next step would be, well, how can we take it to the next level and get even better data, even more granular, better information, less issues with the data, so to speak, okay? So continuously improving upon the data that we have in our hands. And 16, advocating for the effective usage of data in communication and decision-making. So this is a person who's out there saying, hey, that's an interesting decision that you're making there. You know, is there any data that we could use to inform whether or not this is the right thing to do? Maybe we, you know, I'd love to help. Let's figure out how we can assess this situation using data, right? So they're advocating. They're the ones saying, like, what about the data? What does the data say? Let's figure that out too. Do we have time? Maybe you do, maybe you don't. But they're the ones kind of thinking in the back of their minds, what's the way we can have a data-driven component of this decision we're making? And they're advocating for it, again, in tactful ways. Okay, and then lastly, 17, you know, you add that all up. 17 is kind of like the crown. You add it all up. What do you get? You get someone who's spreading data literacy. That's what they're doing, because the way they interact with people in their environment, active and competent use of this language of data, other people learn from them all the time. You pick it up. You kind of take someone's advice, or you follow their model. They're showing a pattern. They're showing a model of how to behave and interact. And so what that does is it spreads things. So that's someone who, you know, at the end of the day is going to be someone who spreads data literacy. So there we go. Okay, guys, I just ran through a lot of it. That was sort of lecture-y. So let's stop right there. And what I'd like to do, now I can do this, we'll see. So we got a slide here called breakout discussion. Okay, so how many people we got here? Let's see how this works. We're going to actually, yeah, cool, we can do it. Okay, I want you guys to talk to each other about which of those 17 traits is the most challenging for you, and which would you say is your strong suit. So you got 17 things there. And let me do this so that so it's kind of weird. What I'm going to do is I'm going to launch what's called a breakout room. Let's see, can I do it? Hold on. Oh, I'm going to have to talk. Okay, so instead of doing that, let's just, I don't see the option here. So that's a bummer. What I want to do is let's just open it up for general discussion, right? So I don't want to be the only one talking. So talk to me. You know what? Let's go. In fact, what I'll do is I'll go back to. I think if there's an easy way to see them all at once. No, I don't really think so. So let's just kind of maybe as I was talking, you were thinking to yourself, which are the ones that you think you are challenged with, and which are the ones that you think are right up your alley. So you guys, I'll turn over to you guys. What do you guys think? Feel free. Anybody, yeah, go ahead.
Through them a little more. Sorry, Ben.
What's that?
Can you go through just like
yeah,
kind of
okay, so now that we ran through them, right? Okay, you're saying to yourself, Ben, I should have said at the beginning, write down the one that you find is easy for you, write down the one that you find is difficult. So now let's go look at them again and then ask yourself that. Which is the one that's like a piece of cake for me? I do that in my sleep all day. And which is the one that, you know, I've been trying, but this one's tough for me. Okay, so knowledge, number one, knows how to distinguish between different elemental forms of data, okay? 2 is familiar with ways that data is collected, structured, and stored. 3 grasps fundamental principles of visual analysis and statistics and when they apply, okay? 4, understand ways to visualize data and their respective benefits and drawbacks. That's knowledge. So think to yourself there, was there one there that you're like, that's my zinger, that's the one that really gets me and I have a hard time with? What about skills, right? Maybe you have a tough time reading, understanding visual displays of data made by others, and you're always looking at it and going like, what does that mean? Or maybe you get it, and that's easy for you. Cleaning dirty data. Oh my gosh, what do we do with all these crazy errors and missing cells? And and NAs and just straight up misspellings. How do I clean all that, right? Or maybe, yeah, I got some tricks up my sleeve to be able to zip through a data set and make it all nice and clean. Combining multiple data sets, maybe joining or blending or unions. Those are all things we're going to do over the course of this next 4 sessions together. How do I bring data sets together? I don't even know, right? Or maybe like, yeah, that's kind of my forte. 7, exploring data sets and identifying relevant facts, patterns, and trends. 8, creating clear visual displays of data to reveal insights to others. 9, communicating effectively using data and information you've gleaned from it. Okay, so think about those skills. Attitudes, do you struggle with believing that data is a language that anyone can learn? Really, anyone? I don't know. Maybe not, Ben. I don't really feel that way. Or 11, feeling confident. Like maybe like, you know, this is something this is always dogging me. Like I just really don't feel like I can do it. This is like my you know, kryptonite here. Or you feel like this is your superpower. Okay. 12, wary of common pitfalls. That's a tough one because maybe some people may say, "Oh, that's easy for me," but they don't know they're falling into them. But that's you kind of don't know what you don't know. But wary of common pitfalls. Okay. 13, considering ethical use of data and the impact on society, and really caring a lot about that. Okay. Behaviors: are you the kind of person that seeks out and creates data? Yes or no? Are you the kind of person who identifies areas of improvement in the data? Are you the kind of person, 16, who advocates for effective usage of data in your environment, your relationships? And then 17, are you the kind of person spreading data literacy because you're using it in a competent way? Okay, there we go. I should have prompted you guys that about the first. I'm gonna make a note about that. Next time I will say to them up front, please write down the thing that you do not like. So then talk to me. Which ones do you find easy? Which ones do you find hard?
I think cleaning dirty data I find easy. I used to be a Salesforce admin, so I feel like I remember always having to just constantly yell at people for what is going on here, why you're entering this weird stuff, and we can't get any good reporting, you know, from this if everything's different. So you know,
Salesforce, you're talking about data people are keying in, right?
Yeah, exactly. Yeah, so I mean, they're always putting in weird data, so I can't convey the idea of how something is working or not working if they're never inputting like the basic right idea, you know, data.
Totally.
Yeah, and I think that goes right in with the idea of utilizing data. You know, like not only do I want to clean it up, but I want to find ways to actually use that data better. You know, like if people are wasting their time to write down something somewhere, it might as well be something that's actually useful. Otherwise, you're just wasting your life, your time, you know?
Well, that's a good point. I mean, why would you spend so much time combing through and cleaning data if you didn't want to use it, right? It seems like that would be like a completely useless endeavor to spend all that time cleaning it up and then just kind of like walk away and not actually take it the next step. So you kind of do all the, like literally the dirty work, right? So then you might as well, once you've done that, you're like, okay, awesome. Now it's ready to go. What can I do with it? So those tend to kind of, yeah, I think go hand in hand. So clean, was there one that was particularly challenging for you?
I think the wary one, because I'm not sure, you know, I want to answer things with data, but I have no idea what the pitfalls are. So it's probably being that I'm excited to want to do things with data, I bet I fall in them even more often because I'm unsure what, you know, what to watch out for.
Got it. Yep. I mean, the enthusiasm is kind of like curb your enthusiasm a little bit, right? It's sort of like, okay, I need to kind of look over. I'm just going so fast because I'm so excited about it. At the same time, now I know I need to stop and look and make sure I don't trip up. So yeah, I can see how that would, those are, because wary, you know, I actually, it's funny you say it because I struggled a lot with that word when I came up with this list because it really didn't feel right. It doesn't feel like it's the one in here that's sort of like, what would you say, maybe, in fact, someone even called me out. One of my reviewers said, are you sure wary is the right word? It feels really negative. And, you know, I almost changed it, but then I came back and said, no, that's the exact right word. I get it. It's sort of like a little bit of a buzzkill, but it's so important to not sit here and think data is some panacea. You know,
I think
we need to kind of really get to the place where, but to your point, well, I mean, it's hard for me to be wary of things I don't know are there and lurking, right? Like the Titanic wasn't wary of the iceberg, right? So, so yeah, that's something to think about. I think it's one of those things where the more experience you get, it's like human nature, right? The more times you stub your toe, the more times you watch out for that one little door jam that seems to get you. So it's one of those things where the more you kind of goof up. I think the best thing to do with that is keep a little ledger of all. I'll give you guys a list of pitfalls, and literally keep a pad of paper and put a tick mark when you, because then you kind of see, oh, these are the ones that are getting me lately, or these are the ones at least that I'm starting to become more aware of. So you sort of like build a list of the ones that you know to watch out for. So hey, thanks for sharing. Anybody else want to jump in? What are some things you think about as far as strengths and weaknesses on this front?
Oh, I guess I'll go. I'm Chris. I'm
Chris.
pretty confident using data as a resource. In fact, in my organization right now, I probably got about 4 or 5 different sections that I'm utilizing Tableau to help them with. But you can go to up to the skills one.
Yeah, sure.
I guess my weakness, actually, one up. Sorry, knowledge.
There you go.
Yeah. I tend to default to bar charts a lot.
Gotcha. Okay.
And,
Yep.
you know, but it's also part of what folks in my organization want. So it's one of those things about showing them different ways to look at it and getting away from just the bar charts and extending, you know, expanding the different methodologies to actually look at stuff.
Yep.
Of course, I've also have some folks who want polygraphs, and I cringe when they say that.
But it sounds like it's a pretty basic palette of visual types that you're usually typically working with.
For the most part, yes.
And you're asking yourself, is there something beyond this that maybe I could be or should be using that I'm just not having, because it's not in the realm of what they're asking for or what is in the report that's been created in the past, right?
It's partly that, but it's also partly dealing with folks that don't understand data as well as I do, or, you know, even other members of my organization. So sometimes you got to keep it at that simple level, and, you know, Mongo see red, so Mongo knows that red bad.
You know, we'll talk more about this in section 3, but week 3, so a week from today. But I'm a big believer that simpler is better usually. And I'm also a believer, though, that it really helps to have a very broad knowledge of the design space, because then those rare times when a maybe exotic or non-standard chart type would be helpful or useful, it really makes a difference. But I also don't really believe that we should add visual flair for the sake of it. We need to be careful about the trade-offs there. So, but yeah, we're going to look at a lot of chart types next week, and I'm trying to devote a lot of time to be able to make as many charts as we can. And also, actually, mostly next Tuesday, we're going to use a fun little tool called Flourish that'll introduce you to all kinds of interesting chart types. Flourish.studio, you probably saw it in the email that came through. And then a week from Thursday is literally an entire Tableau day. And we'll go with the full 3 hours on using Tableau Public to make an interactive data dashboard, and that'll have a few different chart types on there, and we'll definitely go beyond bar charts. So, okay, good to know. That's that. In fact, that for me would be, I'd probably say that's my strong suit, having taught visualization. So I'll be a resource there for you if you have any questions. Anybody else want? Thank you, Chris. Where's home for you, by the way, Chris? I know that I got the email to you. You kind of jumped in a little late, so I didn't get a chance to find out. Where are you calling in from? Let me unmute you there. Hold on. Can you unmute? There you go.
Yeah. I live in New Orleans.
All right. Right on. I was just there. What a cool place.
Were you there for the Tableau conference?
Yeah. I love it.
I was there for it too. So.
Oh, cool. All right. Anybody else have any thoughts about what they struggle with or what they find super easy for them?
Ben, can you hear me?
Yeah, sure can.
So I don't know which one it is, but I don't know if it's creating the data sources, or once you create a data source, how to see what you've created. So you have the tables. It's now you need to know how to create the viz. So it's understanding
this one right here. So probably same one there as Chris, creates clear visual displays. That one.
Yeah.
That's the easy one or the hard one for you, Anthony?
I think that would be the hard one, is kind of wrapping your head around to create the data source, and then how to know how to move it is kind of, for me, like, okay, Does that make sense?
All right. This is helpful. This is helpful. This is gonna, I'm glad we're having this conversation because this will help me tweak things a little bit. What do you think is slam dunk for you, Anthony?
That I like to advocate for understanding what they're trying to communicate. What are they trying to seek? One of the problems that I have is one of the new software that I admin for, there's no real easy reporting. And so I'm hoping to see some of Tableau's new features. So I'm like, okay, that might work. So
Gotcha.
I think for me, it's like I know how to advocate for, I need to see something that I can't see. So I know how to voice, okay, let me see something a little bit different. So, but I don't necessarily understand yet how to use my data literacy voice to answer and get those questions asked and answered.
Got it.
That makes sense?
So totally. I think what you're saying is, correct me if I'm wrong, you know when it's not how you want it to be. And when it's not, when the situation is not helpful for you, when you're looking at a scenario where the reporting is not useful or maybe absent, and you're the one saying this needs to change. And what you're looking
so
for,
it's just
yeah,
is looking for the specific skills to provide easier solutions. So I'm missing the skills portions to understand what I need to look for, if that makes sense.
Yep, totally. So you want to be able to take it to the next level and say, not only do I see the gap, I'm able to find ways to help close it.
Yes.
Gotcha.
Yes.
Okay, awesome. Anybody else want to chime in? I think this is really helpful for me. So anybody have any other thoughts about strengths and weaknesses? This is good for me. I'll tell you mine in a minute, but.
Well, I have an issue with cleaning data. It's just, I find it really boring. Yeah.
It is not fun. I'm going to make it fun for you though. You might think it's crazy. I have an idea on Thursday about how you will, for the first time in your life, actually enjoy cleaning data. And if someone told me I was going to have a good time cleaning my bedroom, I'd say, yeah, right. But it's a cool tool that just came out called Tableau Prep. And we're going to mess around with it. It's so awesome. And you're going to dive in and see how you can it's like a magic wand. And it's just like, you feel like, it's about like, I'm not even good at this. It's a bad analogy for me. Like a household cleaning tool. It's like, that one time you go to probably a rich relative's house and they have like the $2,000 vacuum. And it's like, you feel like you're, a hero, the superhero, like, boom. It like almost does the whole thing. Oh, maybe one of those ones that like vacuums itself or whatever. This one, that you can't do. But yeah, so cleaning dirty data, that's where you're looking at it going like, oh gracious, this is no fun, right? This is not a fun process for you.
It's absolutely not a fun process. And through my career, I had too many large data sets with just totally garbage data that I had to come out with a way to find out, to make reports from, or to do something with it, right?
Yeah. I'll tell you, it's a headache when you see it. And then I think we can find ways to kind of like zip through it a little faster than the manual. And the worst is when it's manual, when it's like this cumbersome cell by cell. That's where it's tough. And then what about the kind of the easy stuff for you then?
The easy stuff is like data storage, data methods. I mean, I've pretty much developed databases for business applications throughout my career.
Beautiful. So this number 2 right here, the ways data is collected and stored.
Yep.
Okay,
Yep.
so that is my weakness. So I'm glad I met you because we can definitely have conversations. Yeah, I'm not a DBA, and I've been lucky in my career, database administrator, to be coworkers with incredibly brilliant people that have done a lot of that setup work for me. And so this whole field of data engineering is a fascinating thing. And I've been more on the analytics, or sometimes called front end, as opposed to the back end of a data working team. So that's my gap. So I got a lot to learn there. Okay, cool. Anybody else? I know we've almost pretty much covered all the bases. So,
well,
yeah.
I feel like this is Maureen.
Yeah, Maureen, talk to me.
I kind of feel like sounds like people have a lot more experience with data than I do. I kind of lean on the cybersecurity side, and I just had an experience with data this last summer that has kind of drawn me to data security and cloud security. So I kind of wanted to get my hands dirty with this, and to me, just from the basic understanding, I think the visualization piece is going to be the challenge for me.
Okay. I'd love to hear more about that story. I mean, obviously within boundaries you're allowed to share at some point, because something got you turned on to this lately. But why is it that you think visualization is going to be the most challenging part for you?
Really just telling the story, you know, or even making sure you're asking the right question.
Yeah.
Um,
Got it.
Yeah. I just want to make sure that I get the story across correctly.
Gotcha. Yeah, it's easy. And this is, I feel the weight of this, you know, it's easy to get the story wrong. There's been many times where I've had to go back and edit and correct what I said, because I found out after the fact that there was an issue with my analysis, or someone's told me that they were misunderstanding the visual that I created. So that's part of the process. And then Maureen, what on the list here is something you look at and say, hey, that actually I feel pretty good about?
Let's see. I think the whole resourcefulness. I'm one of those, I like to learn and I like information, so I gather a lot of information, and I'd probably lean towards probably collecting too much rather than too little.
So number 14 here, you're the person that's diligently collecting and recording things as best you can.
Right.
Got it. Yes, it can be fun to create a data collection plan. It can be fun to, you know, I take a GPS on me in the trail out there with the trails with my boys and such. And yeah, it's kind of fun when you pull together a cool data set that's something interesting for you. And then the analysis and visualization is another thing, but it is kind of fun to get the data there, and you kind of know it's there. I have it, you know, I can connect with it. And I think we didn't hear from you, Jane. So why don't you tell us, what would you say as you look at that list is easy, and what in the list is hard for you?
There we go. Sorry.
There you go. No
coming from where I am, it is about really grasping the big picture, and then because it's not my world, although words are my world, so I'm really interested in that in the story. The wariness and the ethical implications are what just kind of jump out at me, as I would really want to be really careful, get the story right, understand it correctly, and then before I...
So those would be important to you. Those would be things you would see yourself gravitating to, focusing on.
Yeah, they're things that I'm really keen on, and I also am really aware that they could be pitfalls I really want to pay attention to. So
okay.
the other stuff I just don't know.
Yeah, the kind of person where you would, and then so on the side of things that are hard for you.
This is actually grasping the use of the data and how to put it on into a thing to make it show me what it wants to tell me. What story does it want to tell me?
So it's the analysis, really, right? How do I kind of take this data now and answer questions with it?
Yeah, thanks for that.
Yep, makes sense. No, totally. Yeah, you know, it's one of those things, right? It's like the more you do it, the more you feel comfortable doing it. But, you know, the reason why I'm doing this is because I think a lot of people are looking to get started because they realize we didn't really remember when we were growing up in 80s and 90s and earlier, there was not the need to be so good at data. It was not important. And now it is. It's very, very common. So yeah, so these are all great. I wrote down this list from everybody. Thank you for that. Okay, let's move on. So that's the 17 traits. Okay, process. Remember I said, I feel like it's really helpful to anchor everything to a process. So here's my process. It's called QGPs, QGPEAS, 6 steps. Okay, so it starts with a question. And now the question comes to your mind usually because of some observation. Okay, and then you go about asking yourself something. And then you come up with a guess about what you think the answer might be. That's the first step. This is a scientific method, by the way. That's all this is. But I tailored it to working with data. Next is you go about either creating or collecting or finding information in the form of data. So I get it together. There's the data, okay? And then you have to say to yourself, oh, what do I need to do to make sure that data is ready for me to analyze? And that's a tough question if you're not familiar with analysis, because you kind of go, well, I don't know what I need to do to prepare it. And so sometimes you need to actually just start combing through it and seeing what's there and trying to identify problems and issues with it. So that's the prepare step. You're finding those, like we talked about, those issues. Maybe there's typos, maybe there's missing cells, maybe there's errors, maybe it's incomplete, who knows? Lots of ways in which we can need to work with data to prepare it. Maybe I need to take the table over here and join it with one over there, okay? That's preparing data. Now we get into this process where we're just exploring it. And I really want to emphasize this importance of just what I call exploring the contours of your data. We're going to talk a lot about that in 2 and 3. And we'll do some of it today too. But you're just kind of, you're in the mix. You're figuring out what's happening in there. You're analyzing it. You're making visualizations for yourself. This is a very intuitive, it's a process almost like for you. You could be with a group of people, by the way, with a mutual exploration of the data, but oftentimes it's just you in front of your computer exploring, checking it out. And then in the process of exploring, you find hopefully an answer to your question. And then you can then go to this next step. By the way, you will also, and why I have all these crisscrossing lines here is because you will find that you also have brand new questions that you didn't have at the beginning. And so then you might go back to the beginning, and it might even be a more important question or to you a more interesting question. So you get dislodged from that process and you start down a path of going down a different question, right? So I'm here to tell you that's okay. I'm here to tell you that's actually good. That's a great outcome, is if you have a question and you start to analyze data and you get a more important question and you bail on your original question because of this more important question, great. You don't always need to go back and complete the process. It's really counterintuitive. So there's a lot of bouncing back and forth within this little hexagon here. Again, because you don't know what you don't know. And as you discover it, you loop back. Maybe you get to the exploration phase and you realize, oh, I have a new question. I need to bring in a totally different data set now. Well, okay. You're back in the gathering and preparing phase. That's okay. And you don't even have to jot it down or write it down. It's a very fluid kind of a process. It's just helpful to understand the types of steps. And, in some perfect unreal world, like the exact line you'd go through from question to answer, okay, which, as I said, rarely happens because of the fact that this is a discovery process. As you discover, you go down different paths you didn't expect you were going to be going down. That's great. But at some point, you come up with an answer to a question that you think is important, and you come with this conclusion. Here's what this data is telling me. And you formulate that answer in a clear way, and you annotate what you've created to be able to explain it in words. This is where we marry visuals with words, sometimes pictures and images, in order to go to the next step, which is to share with someone. So I'm preparing a presentation. It doesn't have to necessarily be, a 4-hour endeavor making a fancy PowerPoint. It might just be, I take a screenshot of my software and I print it out. I don't know, make a little note on it, run it to the cubicle next door, right? In any case, what you're doing is you're saying, hey, I want to show you something that I found and I want to tell you about it. And then you do the next thing, which is the most important thing that we forget about, which is you say, what do you think? What did that make you think? What questions do you have? Because whether it's an individual or a group of people, will think about completely different things you would have never thought to think about. And that's awesome. And then you go back to the loop and you're like, hey, that's a great question. I didn't think about that. Okay, well, maybe we can find the answer with data. By the way, I'm a big believer that many times this process, okay, you loop around in there, and then you know what happens? You leave the world of data altogether. Because you go to the analog world. You pick up the phone. You say to somebody, hey, I noticed this thing in this data set I was playing with. I made a chart. There's this big spike. Can you tell me what's going on? And they go, oh, yeah, what happened was so and such, such and such. Okay. Well, the data didn't tell me such and such. And we'll get to an example like this in just a minute. All right. So this is a fluid process, QGPs. I don't know how you're supposed to remember that. I thought QDPs, but then it's like QDPs. I don't know. QGPs, it's what I got right now. I'm probably going to change it, but I like it. It's helpful for me, to kind of, again, just think to myself, where am I in this crazy process? Because here's the fact of the matter. And if this scares you, I totally get it. And if you're like, oh no, I'm screwed, I totally get it. but here's what it actually looks like. That's the reality. That's the reality, right? You get into the data and you're like, whoa, 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 I gotta go over here, you know? And then somehow in all of this process of going through, adding data, switching a view, looking somewhere else, asking someone their opinion, looping back in again, you end up with something on the right-hand side, which is amazing, okay? Which is something that you now take and make a major difference in the world with. And it's okay to embrace the fact that it's not rigid and linear. It isn't like a project plan where we go down a Gantt chart and check, oh, I did that phase, I can move on to the next phase. It really isn't like that. It's very, very fluid. And I love it, actually. It makes it so much fun, believe it or not. And the better you get with these steps, the faster you go around this track and sometimes cut right across the darn middle of the darn thing. Okay, so that's cool. Let me walk you through an example of that. So, you know, it's weird to think about it in abstract terms, but this is a bridge. It's called the Fremont Bridge. And it is, actually, Tableau's offices are right there in the bottom right corner. You can't really see them, but that's where they are. I used to park over here on the left-hand side my first few years of working for Tableau. Before they gave me a parking spot, I'd fight for I had the worst bumper ever. It was just annihilated. But I parked over here, and I walk across this bridge to get to work every morning and walked back across it the other way to get back to my car when the day was over. It happens to be, by the way, the lowest, the most active drawbridge in the entire country. It goes up somewhere around 30 to 35 times a day because it's so low. Like every little average sailboat makes it have to go up and down. But it's, I didn't mind. I'd sit right here, this little spot right there, watch these boats go up and down. I loved it. And then I had an excuse for why I was late for my meeting, by the way, which I probably would have been late for anyway. So that's another story altogether. Anyway, there's this bridge. Why am I talking about this bridge? Well, the bridge has, this is another view of it, has a bike counter. In fact, it has two. It has one here. It has one on the other side. There it is, the bike counter. See, what happens is when someone rides their bike across this little counter right here, this little counter goes from 2327 to 2328. And the next one comes along and goes to 2329. You get it, right? The Department of Transportation of the city of Seattle is interested in finding out what's going on with bike readership in the city. That's one way they figure it out. They put these counters in interesting places to be able to see what's going on. All right, so I'm sitting there thinking to myself, I'm walking to work, I'm stopping, I'm seeing these bikes go across, I'm seeing the numbers go up, I'm thinking to myself, I wonder, you know, so what I observe is bicycles crossing the bridge and this counter going up. That's my observation. Well, I'm an inquisitive person. I say to myself, I wonder which day of the year saw the most bicycles crossing the bridge in the last year. Right? Was there a day that had the most? I wonder what it was. And I thought to myself, well, if it was one day, maybe it would be the day of a specific parade. And if you know Seattle, you know the Fremont Solstice Parade is hilarious, okay? This kind of looks like this. There's people riding around totally nude and with body paint on bicycles about a couple blocks away from that exact bridge. It's crazy. It's hilarious, okay? But I figured they have to get to that parade somehow. They got to take their bike over there. So I thought to myself, that day, my hypothesis is the day of the Fremont Solstice Summer Parade. It's good weather. People are riding their bikes, and they're going to cross that bridge left and right. That's got to be the day with the number one. Okay, so again, this is my process. I'm just thinking, right? I'm just writing it down now. So I say to myself, well, I wonder if there's a way for me to answer that question. Well, and wouldn't you know it, the Department of Transportation of the city of Seattle provides this data on a website, on the data, open data. This is crazy what you can find in these open data portals, you guys. I don't know if you've noticed this or been out there, but let me just show you. I'll show you. If you go to data.seattle.gov, let me just drag this on over here. Okay, this is this City of Seattle's open data portal. Your city has one too. All you need to do is Google whatever my city name is, open data portal. And there's data about your city, about transportation, about public safety. You got 911 calls, you got 311 calls, you've got permits, you've got everything. It's amazing. This is so fascinating about the world we live in. But I can go in here and go, actually, I'm not sure if it's on this portal, but let's just see. Fremont Bridge counter. Fremont Bridge, maybe I should do Fremont Bridge bicycle. Oh yeah, Fremont Bridge hourly bicycle counts by month October. See that? How cool is that? Now they drop, and I can see. Let me see the data. So there it is. I can see this data. Okay, got it. This is how many bridges. Wow, cool. Now here's the thing about it. you know as well as I do that if I have data in this format, is this helpful to you? Are you able to figure out and answer that question just by scrolling up and down? Well, that wouldn't be a very convenient way to go about answering that question. It'd be very time consuming. I have to go row by row by row. I have to remember every row above it and which is the most, right? That would take forever. So I can export. See this little button right here? By the way, I'll just drop this into the chat for you in case anybody's interested in playing around with it at some point. There it is. I can go to export. Okay, cool. I can download this as a CSV, comma, separated values, or an Excel file, right? I'll just do CSV, that's cool. Okay, so I did that, and then I got this file. There it is. It's dropping in there. It didn't take that long to open up. It's just, there it is, right? So I can open it up, right? You can do this like it's taking me 10 seconds. I'm actually going about seeking to answer this question about this bridge, right? In a pretty cool way. By the way, I did this in preparation a couple years ago for and here it is, for a presentation I was giving at a luncheon of market researchers not far from that bridge. And I was going to be meeting with them and showing them Tableau. And so I said, okay, well, I want to get data that's interesting to them. And so I was wondering about the bridge already. So anyway, I downloaded it. And I was at this luncheon meeting, okay, presenting with them. And I'd never looked at it. I was kind of like, a little unprepared. I was running into this meeting a little hot, hadn't really had a chance to do much preparation, but I knew I was going to be doing this data. I never touched the data before. And so we were having lunch together. There's about 50 people in the room. I have a screen connected to my laptop. Okay, let's check out the bridge data. We connect to it. Here's what we see. Right? So this is Tableau. We're going to look at this on Thursday of next week. So there are two lines. There's a yellow line for going in one direction because it's on one side of the sidewalk, right? And then there's a blue line for the bikes that are going in the other direction. And we're sitting there and it's like, oh my gosh, look at that. There's these crazy big spikes right here. Unbelievable. And it was just like, huh. And I said to the people there, well, what do you think that crazy spike was? Someone said the solstice parade. Someone said maybe it was the warmest day of the year. Someone said it was maybe a race and they were looping and they went around one side of the bridge, but not the other. Some people said, I don't know, maybe it was bike to work day. There's so many theories flying out about what it could have been that caused this crazy spike. So I didn't know, they didn't know, I moved on with my presentation. But in any case, my answer would have been this. The day of the year in which we saw the most number of bicycles cross the bridge was April 28th. Answer, bing, bing, bing. Got it. Okay, is that the Fremont Parade? Nope, not the parade. Huh, interesting. What happened on that day? I still didn't know. So again, as I said, we moved on with the presentation. About 15 minutes later, someone in the back of the room raises his hand. He's like, hey, Ben, I know. He's waving his phone. Well, I'll tell you, presenting these days is treacherous business because everybody in the audience has got a little pocket with the device in there. And they know more than you could ever possibly know within a matter of seconds. But I stopped the rest of my presentation. It was very interactive, And I said, oh, hey, what was it? Out of curiosity, he goes, you know what it was? It was those counters failed. They had some glitch. And then you know why he knew? It's because he Googled it and he saw this website right here. I swear there's a blog for everything these days. The Seattle Bike Blog, okay? This guy, Monday appears to smash the Fremont Bridge bike counter record. Update, probably not. And then if you look in the comments at the bottom, this little window right here, okay? The bike counter on the lower West Seattle Bridge did not see the same spike, blah, blah, blah. So SDOT, Seattle Department of Transportation, suspects that something is fishy with the number, right? So this engineer, Dong Ho Chang, says, we checked the daily count resolution and there's an unusually high spike in the morning hour. We're checking on the counter, okay? And then down here he says, oh, yep, there were some hours where it had 1,000 to 2,000 extra counts and we don't know why. We fixed the battery, right? So anyway, the bottom line is like it was dirt. It's wrong. Like the counters were glitching, and who knows why? They don't know why. They never figured it out. But they replaced the batteries, and it seemed to go away. By the way, as a side note, look at this. We will adjust the data with errors based on typical volumes and the volumes of surrounding hours. Now that means if you click on the link I just sent you, and you go download the same data, you won't see that spike. But I got the data. I kept it. But the point is, well, what did they replace it with? Some average, I think, like maybe what the hour before was. So that's interesting in and of itself. All right, but here's the thing. So is that just a technicality then? If I say, like, well, the data doesn't tell me how many bicycles cross the bridge on a given day at all. That's why the thing that really hit me about this entire experience is that every person in the entire room, myself included, not one of us, not one, thought to say to ourselves, wait a minute, maybe there weren't really that many bicycles that crossed the bridge on that day. Everybody thought for sure that many, all of our theories, every single one of our theories involved a ton of bikes crossing the bridge. It's the only thing we could think of. We were in this box, and the box is data is reality. Does that make sense? We didn't think to question that that's not what really happened. Okay, so the point is we need to be careful about that because data is not reality. It's not. So instead of saying I'm looking at the number of bicycles that cross the Fremont Bridge when I'm playing with a spreadsheet, no, actually I'm saying I'm looking at, you know, how many times this data set is telling me that the counter, right, registered some kind of event, which is similar to a bike crossing. I'm sure if, let me put it this way. What if I, you know, silly example, what if I was carrying big tubes of bicycle frames or whatever, right? Well, the counter would have gone crazy perhaps, but no one was riding a bike. That's a real example. But then also the thing might just go bad one day, right? So the bottom line is this, and this is really important and a fundamental part of data literacy, is that your data and reality, and there's a big gap between them. I'm telling you, every single time you have a data set, there's a gap between your data and reality. And that's a big pitfall to be aware of. And I say that, but I always, and everybody I ever work with always forgets this. And you catch yourself saying, well, wait a minute, you know, maybe it isn't exactly like that. I can think of a lot of examples of that, but I want to know if you guys can think of any. What are some examples of ways in which your data might not be the same as reality? And I was going to do a hot seat on this where I kind of like called somebody out, but I think we're doing good with the discussion. So I'll just leave it wide open to everybody. What's an example that you can think of either in the world or in your world or in your job or in your community where you might be looking at a data set and it's not exactly one-to-one with reality? Feel free to unmute and let me know what you think.
Well, I guess I've got one. One of the ones that I've got is travel requests for Marines. And the data set that I'm provided has when the request was approved by a certain section, and then when those Marines are actually ticketed. What it's missing is when the request was actually submitted. So, you know, I've got units saying, well, we submitted this 30 days ago. Why am I just getting ticketed now? And that's the data set that we're missing from that. Once I get that, then I'll be able to get a better picture. Because
you don't know when the person, and so in some cases there may be some that are stuck in the black hole, like someone requested it but it never got approved, and so it's not in your data set at all.
Exactly.
Yeah, in some cases it may have taken, you know, an hour. Some cases it may have taken 2 weeks, and that's something that you just can't even do. So yeah, so if you're assuming from that you kind of know when people are submitting, then you would be making a big mistake there. Let me tell you something else that's kind of funny though. You know what actually is crazy is that even if you did have the submitted data, it would be potentially wrong. And let me show you how. So this is coming from the FAA. They actually allow pilots, well, pilots, they don't allow them, they do. Pilots go ahead and submit reports to the FAA anytime they hit a wildlife. Okay, happens a lot actually. It's a little scary, but it does. And let me just go ahead and open up this browser here. And you know what happens is kind of funny. I'll just show you this chapter in this book I'm writing right now. Because if you actually track exactly when they submitted it, like even down to the hour, I mean down to the minute of when they submitted their record to the FAA about when they hit this wildlife, it's really hilarious actually, if you think about it, because here's what you'll see. If you took that data and you looked at it every minute and said to yourself, hey, I want to know when it was submitted and what was going on at what time, here's what you'll see. It's really weird. Here we go. Here it is. This is the reported strikes wildlife by minute of the hour, the 0th minute, and then the 59th minute. Isn't that weird? Do you see what's weird about that data set and what's kind of interesting about it? Let me zoom in so it's a little bigger. I mean, it makes sense, right? The pile is, what do you think's happening here? Instead of me just saying, what do you think's going on? People reporting times of the day.
They're just going to the nearest 5 minutes.
Yeah.
Yeah, they tend to say the top of the hour a lot, more than anything else. And then the next most popular time to report is the bottom of the hour, right? And the next most popular time is quarter of and quarter till, okay? Right? And then it's the 10s, and then it's the 5s. And then you do have some people that are so anal that they'll say, well, it was at 7:01 or 8:59, right? Those people exist, right? So anyway, the point is, that's still a gap, actually. Because it's not the case that somehow I'm flying an airplane and then out of nowhere, it hits the top of the hour and like it's way more likely that I hit something. Like, of course not, right? I mean, this is just reporting. And so I guess the point, I'm glad you brought up the topic of reporting time and date stamp, because there's even errors when you do get what you think is the accurate time date stamp. Not quite. It's a little off. Okay, that's a great example though. Anybody else have another one? Gaps between data and
I just
reality.
have a question.
Yeah.
I just have a question for Chris. Are you guys using DTS? Because while I was doing ticket counter for Tableau, I was talking about using Tableau for DTS, how it could help a lot of people. So I was just curious.
Right now, I'm supporting the Marine Forces Reserve, and they use a lot of this is travel for group travel or even individual. So they use what they call a transportation T3 database, which doesn't tie into DTS right now. And that's the other aspect of it, is the data I'm working with doesn't tie in DTS or in case of
stale data.
DTSR. So we're missing some data, but we're also missing that start date. So yeah, it's not complete, but I'm getting a better picture of where we're at. Much better than where we were.
Cool. Exciting.
Yeah, I mean, these are all gaps to close, right? And it's not to say, this is what I mean about advocating for continuous improvement in the systems and the data that we collect. Because we can get better, and then we have to kind of prioritize, because maybe this is good enough. It's a gap between data and reality, but you know what? It's fine. We don't really need to know if it's 50 or 51 or 52. Like, it's fine. This level of precision and accuracy, no problem. And I think that's also helpful to be able to identify, because that might be an area of opportunity for improvement that's not, the juice is not worth the squeeze on it. Or it might be one that's make or break, like, hey, we got to get the submitted date, guys, because it's making us completely miss a part of the process here, and we're blind to it. All right, what else? Other gaps?
I have one that's also kind of time related. I
Yeah,
worked at a title insurance company back in like the 90s, and as a system admin, and we're pretty high volume place. We'd be running 40 or 50 title insurance claims, or not claims, but applications a day. And there was different departments that have to go through. And the way we had the computer system set up was they'd have a barcode on each file, and you'd scan it when you transferred it from your department to the next department. And so one of the reports that I was tasked with creating was how much time each file was, or the average time each file was spending per department. And if people forget to scan them, then that messes up the data really badly.
Yeah, because they scan it like 2 weeks later or something, and now like that's this crazy outlier that throws off all your averages or something like that.
Well, exactly. Or that it would be like not scanned at all, leaving from one department to next, but then the next department would scan it, and so there'd be like an unknown amount of time.
Got you. Because it's checked in but never checked out kind of a thing, but then it gets checked in again somewhere else, but it never got checked out some of that place. I got you. So it kind of is in this like weird flow scenario where you can't you can't calculate times anymore, and all like durations, and all the formulas get broken. Yep, I hear you. I mean, those are process problems that result in dirty data that make it tricky to analyze data. Totally. I'll throw you a few more, because I'm telling you this, and like I said, this is everywhere. This is every data set you'll ever touch. let me show you a map of all of the recorded meteorites since 2500 BC. You ready? Here's what it looks like. And what's interesting about this data set as I get to it is there it is, okay? Every recorded meteorite impact on Earth from 2500 BCE. And if I look at that data set, I say to myself, wow, you know, it's clear from this data set that meteorites can't swim and they're very afraid of the water. I mean, they're not going anywhere near the water. And how interesting. They know when they're entering the atmosphere how to avoid the ocean. That's insane. And why do they also avoid the Amazon and this little place right here in the Saharan desert of Africa? And what's going on up in Siberia up there, like in northern Canada? It's just like no meteorites going there? I mean, what the heck? I mean, of course not. I mean, this is just basically, there's nobody there to see it and record it. So sure, there's plenty of meteorites falling all over the place there, okay? Here's another one. I grew up in Southern California, and earthquakes was a big deal. If you take a look at earthquakes, here's the line of earthquakes if you take from 1900 up until a few years ago. Now, this should really concern the heck out of us. Shouldn't look at the earthquakes on the rise. Oh my God, earthquake, more and more every year, really? Well, of course, what's happening here is if you break it out by magnitude, it's all the magnitude 6 and 6.9s. The 7s, 8s, and 9s, they're pretty steady. Because why? Well, our equipment got so much better over the course of the 20th century, and we're able to catch and record, more and more of these smaller of the group of earthquakes right here. So it's not apples to apples year after year because we are able to capture a whole different kind of type and level of earthquake, right? So it's not earthquakes, it's, recorded earthquakes, right? So anyway, those are some other things. And again, my point is just that this is everywhere, every data set you work with. I wanted to make sure you guys were aware of that because I don't want to go around, teaching people data literacy and making them think that somehow it's some foolproof way of understanding our world. It really is not. I mean, there's lots of issues with it. And you know what? That's okay. I don't think I think it's good to appreciate that and understand it for what it is. Okay, lots of gaps between data and reality. We've been just hauling butt. So let's just take a break. Let's take a 10-minute break. We have 4:40. Let's come back at 4:50. Everybody take a bio break, grab a soda or a drink or something. Sound good? Thank you guys for sticking with me for so long. Yeah, let's do a quick break. Feel free to turn your video off if you want to get up and cruise around, stretch your legs, and I will be back in 10 minutes, okay? So let's get back in. What we're going to do on the other side of it, we're going to dive into data and actually doing some work together. Okay, cool. Talk to you guys soon. Okay. Okay. Hopefully you all are back and ready to go. Let's finish this up here. Tom's going to have to leave. Tom had to leave. He's going to watch the recording, so that's fine. But this is the hands-on stuff. This is the fun stuff. This is we get to actually play with data together. We've been talking a lot about it, and it's good. But one more little section here of ideas. The idea of the basic building blocks of data, and then we're going to go right into a spreadsheet, and we'll go for it. Okay, so building blocks. All right. So one thing to think about too, as it relates to data, is this notion of epistemology. What that is the theory of knowledge. It really helps us distinguish between things we maybe tentatively believe and that which we can hang our hat on, and so kind of separating out opinion from belief. So my point is that if you look at a data set, what do you think is a more impactful outcome of your session working with data? That you verify something to be true, or that you show that something you thought was true is actually false? Which is the more powerful outcome of those two?
To me, it's to falsify.
It really is, because that's where you actually get new knowledge, and it can sting, and it can be embarrassing potentially, depending on the circumstances. It can be frustrating because it may cost you something, because you may have things tied up in your previously held beliefs in terms of investments, who knows, or decisions that you had made that were contingent on those things being true. So it may be incredibly inconvenient for you that you work with data and find out that what you once thought was true is actually false, but it's a very powerful outcome, and it's actually the much more powerful outcome. There's this philosopher by the name of Sir Karl Popper, and in the 20th century, he wrote a lot of really important philosophical works around our theory of knowledge, our ability to, mostly in the realm of science. But he tried to distinguish between two kinds of statements. One is called a singular statement. That's like me saying, that swan right over there is white. Okay, that's a basic observation about the world, and it's tied to a single moment in time, okay, and space. Then there's another kind of statement, which is a universal statement, where I would say all swans are white. And that's a much more consequential statement, in which essentially I divide up every other thing I might observe, okay, into two kinds of singular statements, right? One that this universal statement permits, in other words, the observation that swan over there is white. My universal statement that all swans are white permits that kind of observation, doesn't it? But it does not permit the other kind of observation, which is that I see a swan that's not white, because that would then say my universe. So that would be an observation, data, that I would collect if I held the belief that all swans were white, okay? Then I would find myself in a situation where I would have to, hold that belief now to be false. And so then saying all swans are white, here's the key phrase, is that we need to be able to state our hypotheses in a way that could be shown to be false if it were. And that actually sounds like an obscure thing to say, but it's really important, because a lot of times we go around saying things that no one can ever possibly say to be untrue, right? It's just, you couldn't show it to be untrue if you tried, okay? Like, there's a God. Well, that's not actually, I hate to say it, but it's something you can't show to be false. You could look all around the world, all around the universe, never find something called God, and you still wouldn't be able to say for sure that there is no God. It's not a falsifiable statement. Okay, so when we're talking about the world of data and science and business and our observations, we need to be able to make sure that we're making statements that are falsifiable. In other words, if it were false, it would be possible. If the statement is written in a way that it's possible to show something's false if it is. Okay, so the statement all swans are white is falsifiable. It isn't false, it's just you could show it to be false. All you would need is a single observation of a non-white swan, which is actually exactly what Dutch explorers found when they went to Australia. This is a photograph I took in Maui when I went there a couple summers ago, like I was talking about with my two boys. There's a black swan right there in the little pond in the hotel in Kanapali. So again, that then shows the statement all swans are white, the universal statement, to be false. Now, I'm bringing all of this up. You say, why are you talking about all this, Ben? Because here's what I find we do a lot of times with data. We fall into the trap of referring to things in universal terms when we probably shouldn't. As an example, and it's such a subtle thing, but I think it's really important. Let's go back to that bridge example, okay? Be wary of times you ask yourself a question and you phrase a hypothesis that sounds universal in tone, like, how many bicycles cross the Fremont Bridge in a month? You may say, hey, you're talking about a specific month, you're talking about a specific bridge. Well, that's not universal, that's singular, right? No, it isn't, because I'm saying how many cross every month, each month, all the time. Which month? I'm not saying, I'm just saying. And so what happens is we get data about a month. Let's say I look at it and said, oh, I pulled data from the internet. The internet's always right. Well, even if I didn't think that, I would say I got data on bridge crossings, and you know what? There were 2,500 bicycles that crossed the bridge last month. But sometimes we do the little slip and we say, oh, you know, about 2,500 bicycles cross the bridge every month. You know, that's the data. That's what the data says. I have data to back up that statement. But I mean, we're right, but it fluctuates from summer to winter. You know, it could be something dramatically shifting or changing over time. You know, the bridge might fall down and then there's a grand total of 0, right? So I guess the point is just, and this seems like a technicality again too, but I find we slide into this dangerous realm of assuming the data we have, which is typically historical data, it might be forecast, it might be modeled or simulated and have to do with the hypothetical or the future. But the bulk of it is historical data. And we tend to assume that trend or pattern that we saw in the historical data is going to apply in perpetuity. It's just this weird little thing we do in our brains because it's so convenient for us to be able to know something that widely applicable that we just do it to ourselves without even knowing it. All right, so the point is just be careful to, when we work with data, you know, there's a couple caveats, right? One caveat is the data is not a perfect reflection of reality. We need to think about things like recorded versus actual, the gap, right? And also, we need to be very specific about the statements we make from it and limit our beliefs about our world to the period of time and place and conditions that created the data that we use to analyze, okay? So that's just an aside. All right, let's dive into the types of data here. There are really, you know, 2 main types of data. You might say, well, the data could be either qualitative or quantitative, okay? It could be something you can categorize or something you can measure, right? So the left-hand side is dealing with categories of things. The right-hand side is dealing with measures or things that we can, you know, quantify, right? So within each of those, you can break it down further into 2. So qualitative variables can be either nominal, in which case there's no order to them inherently, or they can be ordinal, in which case they can go in a specific order. Okay, so we'll look at some examples in a minute, but you know, I might deal with a category of things like, let's say, male or female, or other, or you know, or we can say perhaps you know, a person's name, or we could say a color, maybe it's blue or green, right? So those are things that are nominal. They really have no like meaningful order. Perhaps you could put a color in an order if you're interested in the actual spectrum of light. But for the most part, we're talking about categorizing things that are different in terms of some trait that they have. That trait, like fruits or vegetables or meats, right? There's no like order inherent in the category itself. We might give it a category, give it an order based on some measure, like how much it costs or how much there is or something like that. But the category itself does not have an order within it in meaning, okay? But oftentimes the categories actually do go in a certain order, like gold, silver, bronze, like small, medium, large shirts, right? Like not satisfied, neutral, or satisfied, right? So those are categories of things. You can't really measure them. You can't really like get out a ruler or put them on a scale, or, you know, there's no measure to them in that sense, but there is an order to them. Without a doubt, there's an order to them, right? On the other side of this big divide of data variable types, you deal with the numerical things, right? So numerical variables are ones that essentially have a number associated with them. And those can be either discrete or continuous. So discrete, we're counting integers, 1, 2, 3. There's nothing in between, right? So there are kind of clear spaces or gaps that exist between successive values, and you can never be halfway between them. Like think about shoe size, right? So I can have a size 10 or a size 10 and a half. Can I be in between that? Not really. There's no size 10.25, that at least not that I've seen in any store. Okay, so those are discrete shoe sizes. They have numbers associated with them. Notice, by the way, they weren't integers. I said integers, but that's not actually true. They're discrete. They actually had a 0.5, right? I have shoe size 10.5, but it isn't actually, yeah, so in that case, I'm not using an integer there, but I am dealing with numbers that have nothing in between them. There's nothing there. Or they could be continuous, which is very common, which is numerical observations that lie anywhere within a range of values. If I want to measure the height of my kids, you know, they come back a couple months later, I measure them again, they're going to be off by some sliding amount, right? It could be an inch, it could be half an inch, it could be a quarter of an inch. I can keep dividing successively, get something else in between. There's always something in between, in fact, ad infinitum. So those are continuous variables that have this continuous, a numerical observation that can lie anywhere within a range of values. Let's look at some examples, because this is all very abstract and nice for textbooks, but what does this look like in the real world? Let's say we got a list of people that are in a school. Okay, so they're in school, they're going to school, and we've got, okay, so on the left-hand side there, we've got their name. Well, their name is a nominal category. It's a nominal qualitative variable. That's data, their name. It's in a spreadsheet somewhere, right? John, Allison, Claire, Brian, Andy. Okay, that's nominal. There's no order to it. You can't quantify it. It's just a name. Okay. Also, again, their gender. That's just it. There's no order to it. It is what it is, right? Ordinal aspects of them could be their grade. Okay, so they have a grade. You have an F. You have a A, B, C, D, right? Maybe it's a C minus. Maybe it's a B plus. Those categories go in a specific order from best performance to lowest performance. Also, the shirt size, right? So shirt might be extra large, medium, extra small. We talked about that. That's a qualitative data variable, right? That has order to it, but there's no number to it. On the quantitative side of things about these fabulous students is the number of detentions. So how many times did they, and you might say, well, that's discrete. I can't have half a detention, right? I either have 3 or 4 or 5. I don't have 3.5 or 3.4 or 3.41, nothing like that, right? So it's just strictly an integer. It's a discrete variable. It's quantitative. You can count it, but there's only one or the other. There's nothing in between. Also, how old they are, that's an interesting one now, because it gets to be a little bit of a gray area. And you might say, well, Ben, age, if I'd specify their age in years, then it's a discrete variable, isn't it? But actually, they've been living for a certain amount of time since the moment they were born. A certain amount of time. And that amount of time is literally is continuous, isn't it? If I were to capture it in seconds, I could take fractions of a second, fraction of a second, if I had the ability to do that, right? So I could actually share their age in a continuous fashion if I wanted to. And this is why these variable types get tricky, because sometimes it can be one or the other, right? So it depends. If all I want to know is what year they are in terms of their age, okay, then that's a discrete continuous variable. It can only be 17, 18, 19, right? But if I want to capture the amount of time they've lived, well, that's a different story. I can definitely compute that and capture it continuous. The one I included in here was height in inches. Height in inches, by the way, it might also, if you drop it into coarse enough buckets, it might just be like, well, you can only be 5'6", 5'7", 5'8". We're not going to let you capture, or the resolution of our measurement system doesn't let you record, or the database we created doesn't let you put a fraction of an inch in there. Again, that depends. That would be a scenario in which their height would be kind of more of a discrete quantitative variable. So unfortunately, as clean as it looks, it is sort of dependent on how we specify some of those quantitative variables by granularity. Okay, but conceptually, continuous quantitative variables are ones that you can always get more and more granular. You can always go in between two variables, two values. All right, hopefully you guys get it. One also thing to think about, notice that all of these ones on the right, these three right here, okay, so continuous, discrete, and ordinal, I'm putting a little box around them because you know what, those are all ordered, right? But then the only one that's not ordered of the four is the one on the left, nominal. That's the only one that's not ordered. The other three, they're ordered. Okay? So it's another way to think about breaking them up. Discrete. and continuous. The only one that's continuous is the one on the right, continuous. The rest of them have discrete values, and there's nothing in between two values. So that's another way to kind of think about it. Even though this one's called discrete, technically also these qualitative variables are discrete because, again, it just means there's nothing in between two successive values. Whereas continuous is unique in the sense that you can always split two variables. It's the only kind of data variable that is like that, where it can take on a value anywhere over a particular range with infinite possibilities and infinite possible values between any two. That's just continuous data. That's how it's, unique. Okay, so let's think of an example here. Let's talk about the Olympics. And oops, sorry. Look at this photograph right here. We got, I think this is a relay race of some bicyclists, I believe. Maybe it's a velodrome or something like that. I don't know. I've never watched that. But in any case, let's talk about this example. So qualitative variable types, athlete name and the country. So each one of these athletes has a name, and some are from New Zealand, some are from Great Britain, and some are from Australia. Okay. So the country that they come from is a nominal category. There's nothing in between, I guess maybe on a map there is, but those are just lists of things, okay? An ordinal qualitative variable type would be the medal that he won, gold, silver, or bronze. That's a variable, it's qualitative, and it goes in order. As well as within a team, right, your relay position. You might be the anchor, or you might be the person leading off, right? Where are you in the order of your team's relay? If you want to specify that as 1, 2, 3, or 4, that would slip down here into quantitative discrete, where my relay position is 1 or 2 or 3 or 4. That's a number, it's quantitative, and it's discrete. You can't be the 2.5 ordered rider, right? There's no meaning to that. Quantitative variables, discrete ones would be the age in years. So this rider is 25, this rider is 24, this rider is 23, right? And then their rank. Hey, of all these 12 riders, the one that was the fastest was this one right here, who had, whose rank was number 1. And then there was number 2, 3, 4, all the way to 12. So the number of my rank in terms of my finish time puts me in a list of riders from 1 to 12. My order, my number, my rank in that list is a discrete quantitative variable. You can't be anywhere in between the 3rd and the 4th ordered ranked rider. There's nothing in there. There's nothing between them. Continuous variables would be, hey, how maybe their trainers are really carefully monitoring their health, and they say, hey, you have to lose a little bit of weight before the race, or maybe gain a little bit of weight, right? So they're measuring their weight very closely and carefully in fractions of a gram. Okay, that would be continuous. And then finishing time, someone's clocking them, and they've got fractions of a second, right? So it's like, oh, hey, the 5th ranked rider finished his section in, I don't know, 5 minutes, 0.34, 0.32 seconds, right? Whatever that looks like, right? So it's really fine granularity in terms of the amount of time that it took for them to perform their feat there. Okay, so that's an example of a real world. Again, so my point is that what I'm trying to do here is say, like, okay, I can look at these categories in this fancy flow chart all day, and you're not going to understand it because it's not the real world. This is academic. This is textbooky. But it's just something that helps us categorize the way we measure and data we collect about the real world. It's just that the thing we're measuring goes in one of those little buckets. And so it's just helpful to kind of see. So here's an example I'd like to ask you guys. If we talk about shoes, right? So let's think about shoes here. Let's consider data about shoes. So think about this, right? And since we're trying to catch up on time, let's think about the first one there. So shoe satisfaction. How satisfied are you with your shoes? The first one on the right. Customers rate their shoes on customer surveys and such. And what type of data is that? Shoe satisfaction. Is it nominal? Is it ordinal? Is it discrete or continuous? How satisfied are you with your shoes? Highly satisfied, neutral, not satisfied. What kind of variable type is that?
Ordinal.
Ordinal. Correct. It's not a number, but it has an order. Okay. Next one, your shoe size, e.g. 11.5. What type of data, what data type is that?
Discrete?
Yes, it's a number, right? 11.5, but there's nothing in between it and 12. That's it. So it's a number, quantitative, but it's discrete. The brand of shoe, Adidas, Nike, Reebok. What kind of variable is that?
Nominal?
Correct, right? So it's either one or the other, and it's a name. That's why nominal is easy, because usually it's a name of something, right? And then, of course, by process of elimination, the last one there, how heavy the shoe is for shipping purposes or what have you, right? Its weight in grams, okay? That's a continuous variable. So there we go. There's the matchups right there, okay? So you might say, okay, got it, right? So again, all we're doing is we're looking at the world. There's a lens about that world. That lens is the way we collect data about the things that are around us that we're interested in understanding and studying. And you may say, well, okay, so what? I know what variable type is and what it's called. It's hugely important, because when we go to visualize data, when we talk about chart types, right, your discrete variables, those three that are discrete, nominal, ordinal, and quantitative discrete, right, those are all going to make buckets of things, right? In this case, it's year. Everything is in a bucket of 2013. That's a discrete variable. Everything is a bucket of 2014. That's another bucket right there, right? Your continuous variables, maybe this is revenue that the company made. Who knows, right? That's going to make an axis, and that's going to be able to let you draw things like bars or lines or position things in space, right? A scatter plot, where the dot goes, right? How far to the right, how far up. Those are on axes, and those axes are formed by your continuous variables and only your continuous variables, right? But all of the other ones are going to create these buckets. And colors too. Continuous variables make these sliding scale color gradients, where something gets slightly darker and darker and darker, right? That's a continuous variable being mapped to color, being dropped into a color encoding, where I'm saying I want something, the darkness of it, the hue, or the color saturation, okay, to be a function of some number. Maybe it's your weight, maybe it's your height, maybe it's how much you make, right? I want to map that to a color. Well, in that case, you end up with these two on the top right here. But if you want to use a discrete variable, like say the country that those riders were from, or the shoe brand that the box that I bought, right? That's going to give you a different hue, and that's just a fancy word for like a different primary color. It could be any color, but there's no relationship and there's no sliding scale. There's no notion of like in between these two colors. They're just a different color to capture that it's a different kind of thing. Okay, so that's what I wanted to bring up there, is that it really matters. Continuous, and we're going to come back to this again, because, and as we learn Tableau and other tools, we want to really ask ourselves that, wait a minute, what kind of variable are we dealing with here? Because once you think about that and you say, well, I want to understand shoe brands and I want to compare them. Oh, okay. So what you want to do is create buckets for each shoe brand. Okay, well then that's interesting. That's good to know. And that's going to inform how you visualize that data. We're going to get back to that. Cool. Let's keep on the sports theme here. We're going to get into Excel, sorting, filtering, and formulas in Excel. We're going to use NFL player data. This was from a pretty remarkable play that just happened a couple of days ago. Sorry if anybody here is from Boston. I don't think anybody is.
I'm leaving now.
I ticked somebody off. I'm sorry. I thought as soon as you found out I was from Seattle, I was going to lose you. Okay, so let me send a link to you all. I want you to download a data set that I have, and it's just called NFL Active Team Rosters. So hopefully you have a data.world account. I think actually even if you don't, you should be able to click in here, and you should be able to go in there, okay, and download this data set. Let me know if you can. Let me put the link in here. I'm going to send this to everyone, and go ahead and click on that link. Okay, once you click on that link, you're going to see this, right? This is just a little data. Data.world is an amazing platform. I think in my email to you, I had you guys check it out. And you want to go in here and click on this data. Oops, sorry. Did you all, oops, 1 second. Spam caller.
Oops,
Awesome.
Can't find that page.
What's that?
It says, oops, can't find that page.
Oh, really? Let me try again here.
Again, same thing.
Okay, I think maybe I need to make it public. Hold on, let me just see.
Yeah, you don't have any public projects or data sets.
Yeah, okay, I need to make that public. I just did not do that. Okay, so here we go. want to make this one settings, maybe settings, open.
There you go.
Okay, hit refresh. Sorry about that. Now you should see it.
Winning chicken dinner.
Bingo. Okay, everybody there? This is just a portal that lets you go in and put data sets there. That's it. It's really cool. Hit this little down arrow right here. So can you see my screen? Now, you're probably bouncing back and forth between my screen, so I'll leave it here for a second because you want to go off the screen. And when you see here this page, it's a little description of what it is. You get down here to this little table. Just hit the little down arrow, download. Everybody able to do that? And it should show up in your downloads folder. And then when you open it, go ahead and go to your downloads folder, or you should hopefully be able to click it in the bottom of the browser right there, okay? And then you should see this, right? Here we go. Everybody got that? You got Excel, you click on your active. What this is showing you is all of the players. Sorry, question?
It hasn't opened properly.
Ah, okay. Is it still downloading or is it there but not opening?
No, I continue to get the same page that says, oops, we can't find that page.
Oh, fascinating. Okay.
Yeah. I've closed the link and
I've got it. So
okay, I'll tell you what. I will give it to you a different way here.
I had a problem too, but I had to log in and then refresh.
Are you, Maureen, are you logged into data.world? Oops, you're muted. Sorry, say that again.
sorry. I am not. I just pulled it up in the browser, but I didn't have time to create an account before we started.
Oh, no problem.
So
I
is
don't
that the
think.
problem?
Yeah, no, I don't think so. I think anybody should be able to download it. So let me just do this. Let's see. Okay, I know what I'll do. So Maureen, what I want you, I'm going to give you a different. Oh, I need to do one thing real quick.
I am on a Mac as well.
Yeah, me too. Me too. That should be cool. No worries there. Let me tell you one thing real quick.
You do have to be logged in Data World in order for you to be.
Oh, is that right? Okay,
Yeah.
well, good to know. I wasn't sure about that or not.
Yeah, you
All right,
won't be able to see the link because it has to authenticate you that you have access to view it.
Got it. Okay. Well, I can give you another link. This is one to Google Sheets. They have the same folder here in Google Sheets. So let me go ahead and let me go ahead and drop this one in there too, then into the chat. Here you go. That's the same file in Google. That is set, I think, to, let me make sure. Yep, anyone who has a link. Got it. Okay, so you should be able to see that. I should pop up a little icon right here in a second when you click on that one. And you should, there you go. Okay, got it. Now, come on over here to File and click on Download As. And then just go ahead and click on Download As Microsoft Excel. Either way, data.world or here Google, either way should be fine.
Okay, so I missed your showing how to do download from data.world.
Oh, okay, yeah, the data.world link, if you got to kind of go into this page, and then it's kind of hidden. There's like a little down arrow right there. You see it? It's like right at the head, the banner of the little table that you see halfway down the page. And then next to Explore, you have a little down arrow. Did you find it? Right there. Okay, everybody good? Everybody got, sorry, go ahead and say again, Maureen.
I have the Excel.
Yes. Okay, you got it. Jean's got it. Anthony's got it. Yep, okay, good. All right, so this is showing every player that was on the preseason NFL roster for every team, every position. So it's, you know, it's a data set of a whole bunch of football players. So, you know, we can think about this in terms of our variable types, right? So if we look at these, we can say, well, you know, they have an ID. the player ID 1, 2, 3, 4. It's just like a row number, really. So that's a discrete quantitative variable. All right. Their name, obviously, is nominal. Their jersey number, that's also discrete because you can't have half a jersey number, right? So it's a number, but it's not continuous. It's discrete. Their position, or the linebacker or quarterback or wide receiver or whatever, that's nominal. Okay. Their height, that's in inches. I mean, it's technically continuous, but we could debate that because it's only, you can only have, it looks like you can only have feet and inches there. So that's debatable. Their weight, I would probably treat it as continuous, even though it looks like they rounded to the nearest pound. I would still probably say it's a continuous variable. They could measure it at a finer level of granularity than that if they wanted to. All right, their age here, I would probably call it discrete because they're not capturing fraction of an age, right? Their experience level, how many years of experience they have. Well, that's interesting. That's actually R for, this is where it gets weird, okay? Because look, what did they do? This is right off the website. They have R for rookie. That's what that stands for, right? And then if you have more than 1 year of experience, like this person right here, Curtis Samuel, he has 2 years of experience. We can scroll down and see that we have lots of players with multiple years experience. If we were to scroll down, 2, 3, 4, 1, right? So that's an interesting question. Is years of experience, what kind of variable is that? Well, it's mixed because they used R. So what most software programs is going to do, notice how Excel has R to the left over here, and then 2 is on the right. And that's because, and it's kind of weird, like, why did it do that? Why did it throw R on the left and 2 on the right? That's because Excel is trying to tell you I'm interpreting this value as a string, so it's on the left-hand side, whereas I'm interpreting this value as a number, quantitative, so it's on the right-hand side, okay? So this one's sort of mixed in a weird kind of way that's going to give us a lot of frustration. It's good to see that and notice that, right? Why did they use R for 0 years of experience, right? That's a little bit confusing. That's what they did. You know, people do weird things with data. What can you say? College. What college do they go to? Clearly nominal. What team do they play for? One of the NFL teams. Clearly nominal. Okay. And do you guys have a column K or no? Do you have height twice? No. So you have the last one you have is team, right? Can someone let me know what happens to you after J? Is it done after J? There's no K?
No.
I got a K.
I'll get rid of it. Do you have little down arrows here or no? See the little down arrows in all the row 1? Do those exist for you or no? Or is it just the ID? See what I'm talking about? This little row, these little down arrows here and here and here. Do you have those?
Mine has those.
Okay. The reason why that's there is if you click on the tab right here, data, click on the data tab, and you'll see this little filter icon is pressed down. If you have an older version of Excel, it's still in the data tab and it's filtering. So that's neat. We'll turn it off for now because we're going to start. We'll get back to that. We'll get back to that. Okay. That's the data set, right? So I want to start. Let me tell you, I could give you guys the question that I had in my spreadsheet, but I want to know what you think. What questions do you have about this data set as you're looking? Maybe you do or don't care about NFL players, but does something come to mind? What's a question that you have as you observe this data set?
What's the average height or weight of a certain position?
Yeah, okay. So we can start talking about averages. We're going to get to that. We're going to get to that. Let's averages and central tendency. That's a topic we're going to cover in the 3rd class. But yeah, I want to know, like, what's the average height, right? That's a very common question. We think about things in terms of averages all the time. I have actually a really interesting example about averages and football players that we want to look into to understand that when we see an average, it may not be what we think. Let's just think about most and least. What about this? What if I want to know which player is the oldest? Okay, there are. Now, first of all, let me give you a trick. Put your cursor in A1. So it's a box highlighted there. If you have a Mac like me, hold Command and Shift together at the same time and then hit the down arrow. If you have a PC, use Control and Shift and then hit the down arrow. All together, all 3 of them. I usually hold Control or Command first then I hit shift, then I hit down. What does that do? That scrolls all the way to the bottom of your data set. It's kind of a keyboard shortcut. So this tells me I'm dealing with 2,875 players. I can tell by how many rows there are. Okay, Control Shift down, that's shortcut to the bottom. And then you can imagine Control Shift up or Command Shift up, that gets you to the top. So that's helpful. So I just want to kind of, again, my first piece of advice to you as you stumble on a data set is ask yourself, how many records are there? How many records exist in this data set? A record is a row is a player. There are 2,875 players in this data set that I'm looking at right now. But I want to know who's the oldest, okay? So it is not right now, how is this data set arranged? How are these rows? How do I know which row comes after which row? Does anybody know which is the variable right now that's telling me the order of the rows?
Mine is age.
Yours is based on age?
Mine's based on age.
ID.
I've got ID, but then it goes by age.
Yeah, it looks like it does, doesn't it? Someone came up with IDs for these players that seem like, at first blush, at least if we look at the top of it, right? All the players who are 20, or at least, well, what I can say for sure is a whole bunch of players who are 20 are listed here as numbers 1 through 8. And then it seems like right after that comes all the 21-year-olds. Well, I don't know what all, but I know a whole bunch of them are there, right? And those seem to be the next ones, then 22. So yes, it seems like right now we have an ID determining the exact order of the spreadsheet. And it looks like that's mapping in rough terms to the grouping in terms of their age. So if I wanted to know the oldest player, this seems to me like what I could do is just scroll to the bottom, okay? And then what happens when I do that? Well, this is actually important for us to do. So what did I do again? I went to the top, I went to the age, first column in age, G1, and I hit Command Shift down, or for PC users, Control Shift down. That got me all the way to the bottom. And what did I find at the bottom? Well, it looks like there are, if you highlight all of them, the NAs, do you see in the right over here, it says count 17. Do you see that in the bottom corner there too? That means there were 17 players that have NA for their age. Why? Well, who knows? That's a great question. I don't know. It would have to be answered by the people who created the data set for us. For some reason, at the point in time that they published this to the internet, they had NA values for 17 of the players. But the oldest player in terms of ones that actually have an age is Adam Vinatieri, who's a kicker for the Indianapolis Colts, and he's 45 years old, okay? So there you go. There's the oldest player. Now, hit Command Shift up again, and I want to show you how you can, let's say, who's the player with the most years of experience? I would guess it's probably Vinatieri because he's so old, but maybe not. I don't know. How would I determine that? So let's do this. Hold down that. So instead of doing the filter way, by the way, the filter way to me is the preferred way. I'm going to click on sort, okay? So go to the data tab and click sort. And now you get this window that pops up and says, how do you want to sort? Well, we want to sort on, click on the column right here in the down arrow. I would like to sort based on experience. Okay, how do you want to sort? Oh, I want to sort the values, and I was looking for the player with the most experience, so I'll take the largest number and put that at the top, and it goes down to the smallest number. I'm changing the sort of my database. Okay, and then I'll say okay. And it looks like the R's are at the top, which is ironic because actually those are the rookies, the players with the least amount of experience. So I have to go all the way down to row 737 before I find our good friend Adam Vinatieri there with 23 years of experience in the league. But Excel didn't know what to do with the R's. It put those at the top. It put the letters above the numbers in the sorting order. So R's are, what if we said to them, you know what, actually, I don't like the way, this is dirty data. I don't like the mixture of the R. That's 0. I want that to be 0. Okay, let's do this. Click the entire column H. So you have the whole thing there, right? You see the whole column. You click H up at the top, so it literally selects everything, right? Okay. Now what we want to do is find a way to replace all the R's with zeros. Now that's actually modifying our data, isn't it? But we say that's a more useful way to be able to analyze my data. So it is in the, it's sometimes hard to find it, which is ironic because it's called find, but it is right, sort and filter. One sec. It's on the home tab. Okay, got it. Yeah, it's, so my icon is hidden. I just actually installed this one. So what I want to do is pull this down. Nope. It's part of these guys. It's part of these guys. You might have it. You might have a little magnifying glass there. Mine's missing. So I need to actually go in and I think I need to modify this guy real quick here. Okay, I'm gonna have to find mine over here. Find, yeah. All right, so usually there's a little binocular icon over here. And again, mine's missing. I have to change my defaults to add it there because it's super useful. If yours is there, click on the binocular icon. For me, I'm gonna click on edit at the top menu and go to find and then hit replace. Okay, so top menu, edit, find, replace. And I'm gonna find what? Oh, I'm gonna find the letter R and I'm gonna replace it with a 0. So the NFL, when it put that out there, it should have just told me rookies have 0 years of experience because that's why they're a rookie. And then I'm going to say, okay, well, you're going to find, and that's very important, by the way, that I'm highlighting only the column H. Because if I highlight everything, it's going to literally find every R and replace it with a 0. Or if I'm highlighting the wrong column or only one cell, it'll only do that job based on what was selected when I came into this menu. So hopefully you see a nice gray bar going all the way down H. And I'm going to take all the R's there, right? And I'm going to replace it with a 0. And I'm going to say replace all. Boom. All done. We made 735 replacements. Great. Okay, so I can close this window. And now instead of R's here, I have zeros, right? Did that work for you? Now all our rookies have 0 years of experience instead of R. Thank you. That's what I wanted in the first place. Well, I had to go ahead and edit the data. Let's redo that sort. Okay, let's go back to the data tab because remember, I was trying to find out which is the player with the most years of experience. We'll go back to data and let's do the sort again. Click sort. And now see, it's already there. It's already saying sort by years of experience. Yep, the value there I want is experience. Sort on those values, largest to smallest. Great. Okay, I'll say okay. Now it'll redo it and it'll put all those zeros to the bottom, right? Did it work for you? If you hit Command Shift down now, again, to go to the bottom of column H, you'll notice that all our rookie buddies down there, the zeros, they're all at the bottom now because it redid the sort, and that's the smallest number. The smallest number in the experience column is 0, now not 1 like it used to be before all the rookies had levels of experience of R, not 0. You're with me? Great. Now check this out. I never use this sort, by the way. Hardly ever. Well, sometimes I use it if I want to do like multiple sorts. Like I want to sort this and then that and then that. So we'll get into that later. But what I usually do, everyone, I just hit this filter icon. Hit that little filter icon. So you push it down. It looks like it's gray. So it's like pushed in. And now you get all these arrows here, right? Well, what we can do then is let's find out who the heavy, did you get it? Did you hit the, anybody have an issue there? If you hit filter, that little icon right there, it should give you those little arrows in the right of every cell. Again, all we're doing now is we're dealing with our data types and we're trying to find ways to sort the table in ways to simply, quickly answer questions that we might have that are interesting to us, okay? This is not, the reason why I'm doing this is because, you know, it's simple to go through and figure out some very basic questions without having to make charts and graphs or do anything fancy. A lot of times we can just sort the data and it'll give us a question. Like if we have a question about max or min, most or least. For example, if I want to know who the heaviest player is, now instead of going to that sort icon like I did, I could if I wanted to. Instead, I'm going to hit the down arrow next to weight. And see that right there? I want to sort it descending. I want to sort it descending because that means I want the largest number at the top, and I want the numbers to descend, to get lower and lower as I go down. Lower weights, higher weights at the top, lower weights at the bottom. Okay, so I can hit descending. Now I see that my heaviest player, Trent Brown, plays for the New England Patriots out of Florida, right? 25-year-old guy, he weighs 380 pounds, big guy, okay? But again, I answered a very easy question. All I did was resort it. And instead of using the sort icon, I used filter. I do this all the time. Again, I just usually, as soon as I open a spreadsheet, for me, almost always, I punch the filter tab because I'm going to do this kind of thing all the time. You know, it's very common for me to want to resort things in a certain way, right? If I want to see who's the lightest player, okay, well, I go back into that arrow in the weight column. WT stands for weight. And I just check ascending. That means it's going to switch the order so that the player with the lowest weight is at the top. Cairo Santos is 160 pounds, 26-year-old on the Jets, right? There we go. So that was easy. Sorting data in tables and spreadsheets. Again, that is something that is very important step to be able to do when we interact with data is sorting, okay? Filtering. What if I said, you know what though, I only care about the lightest player on the Seahawks. I don't want to know the lightest player in the whole league, just the lightest player on the Seahawks. Well, now because I've filtered, I can go into the team name, right, and hit the down arrow. Now, I don't want to sort alphabetically based on the teams. That's not what I wanted to do. I wanted to limit my data that I'm looking at. I wanted to filter or essentially focus my analysis on a subset of the data, not all of the data. Right now, that's every team. I only wanted one team. So I uncheck select all. Now everything goes away. So then I go down to Seattle Seahawks and I check that checkbox. Now I see that it's still sorting, by the way. How do I know? Well, first of all, notice how the down arrow changed. See the little filter icon in the team arrow? You see what I'm talking about there? Instead of having just, let me make it bigger because it might as well. Instead of having, there we go, just the down arrow, it now has, like college just has a down arrow, right? Well, it has a down arrow with a little filter next to it. Well, weight has a little down arrow with an up arrow next to it. The down arrow for select, and it has like an open, like a different kind of arrow pointing up, meaning it's sorting this field ascending. Ascending means it's going up and up and up and up. As I go down the table, the values get higher and higher and higher. So this is telling me it's sorting my weight ascending. This is telling me, this icon is telling me it's filtering my team to a certain value, right? So sorting, filtering. I can answer finer and finer granulated questions, you know, based on these questions I have. So I can know the oldest player, the youngest player, the heaviest player, the lightest player on just one team, right? So let's go back to, for example, I can change the filter, right? So let's say I only wanted to see wide receivers on Seahawks. I can go even more specific than that. I can go over here to position, right? So I still have my Seahawks filter on, right? Well, and I can go to position, hit the down arrow, all right? And I can unselect all the positions, POS for position, scroll all the way to the bottom and check wide receiver. Now I'm only seeing wide receivers on the Seattle Seahawks, and they're still sorted by how heavy they are. So Tyler Lockett at 182 pounds is the lightest receiver on the Seattle Seahawks, okay? And I can also, since the values are so small now, I can see the heaviest, Brandon Marshall. Actually, he got cut, but that's neither here nor there. It actually is interesting. I mean, this is again, he's not on the team anymore. And that's because I pulled the data set at the beginning of the season in the preseason, and he got cut midway through the season. So that's also an interesting point. Sorting, filtering, really, really easy with Tableau, with Excel rather. I think it does a great job of it. So now if I wanted to undo those filters, right, I can just go back into the team filter and just check all. See how it's got a minus sign there? That's telling me the blue means there's something selected, but minus means it's not all. But if I check this, now I check all again, okay, all the teams are back in there. Again, I'm sorting wide receivers for the entire. The lightest one is J.J. Nelson on the Arizona Cardinals, weighs 160 pounds, right? He's a wide receiver. It's still sorting, but I can go back into the position now, and I could switch it to a different position if I wanted to, or I could just say select all. Okay. So there we go. Sorting, filtering, easy to do in Excel. Let's start talking formulas now because we're almost out of time. And I want to go over something really cool that you can do with Excel. Do you guys all know BMI? Is that meaningful to you? Body mass index is basically a function of your weight and height. In fact, the way you determine it, I think it's a very controversial health parameter, by the way. Like some people believe in it and swear by it, and some people really hate it. But I'm not really passing judgment on it. I found it because I thought it would be really interesting to see how we could do some formulas in here. But the way you calculate someone's BMI, body mass index, all you do is you take their weight in kilograms, okay, and you divide it by their height in meters, and you square their height. So you multiply the height by itself, okay? That's squaring, right? Height times height equals height squared. But it's got to be in kilograms and meters, so I have a problem right away, right? Which is what? Well, my weight is in pounds, and my height is in feet and inches. Well, the first one's pretty easy, so I can convert my height from, my weight rather, from pounds to kilograms. All I need to do there is find the conversion. And it's amazingly easy these days. Google does a great job of this. If I just go converts pounds to kilograms, right? It tells me right away that 1 pound is equal to 0.453592 kilograms. So I can make my own table over here. So put your cursor in K1 and say weight in kg. Weight in kg. Now, I could, if I wanted to, take this calculator right here and do them one by one. I wouldn't do it. I would do it this way, not this way, right? This way. And punch them in there and type in the numbers. Oh, I can do that. I can do that. That's going to take me a long time, isn't it? 2,800 rows. Wow, it's going to take me a long time. Excel will do it for you. It'll do it for you. What you do is hit the equal sign first. Hit the equal sign. Now you're telling Tableau, I'm going to make a formula. I'm putting a formula in this cell. That is, I want you to do some math for me, Excel. Okay, I'm telling it that by putting an equal sign in there. I'm going to say take the weight, right? So click on that cell right there, F2. And use an asterisk, Shift 8, gives a little star-shaped asterisk, right? Times, what was the conversion factor? 0.45, bear with me, 3592, sorry, 3592. There you go, 453, you can probably do 45 and you'd be fine for the purposes of this exercise. Now this is telling me, Excel says, okay, I'll take the value in F2, which happens to be 160, and I'm going to multiply it by this number I've typed in. Okay? Everybody do that? Now hit enter. 72.57472 kilograms is how much Kairos Santos weighs. All right. Now, if I hit Control C and copy that, put it right next to it, below it, click the cell below it, K3, okay, and then hit Control V to paste it, I get the same number. Why? Well, the person below, J.J. Nelson, has the same weight, 160 pounds. Click in that cell. So, but notice up here, what is it? It doesn't say F2 anymore, does it? It says F3. And if I click in the f of x, this function bar up here, it highlights the cell for me to tell me it's blue, right? See the blue F3? It highlights this blue right here to tell me which one it is. All right. So what happened was when I copied it and pasted it, it didn't carry F2 down. It said, oh, I'll assume you want to go to F3. Okay. Now, if I click in K3, see the little square in the bottom right corner? I can just click that and click that little square in the bottom right corner and just drag it on down. Just drag it down a few rows. Now I go from 72.5 kilograms to 73.93 kilograms. That's because Dante Dion is 160 pounds, right? So I'm taking now F5, and multiplying it by 0.453952, okay? And I get a different value for the kilograms. Now what's super cool is you can just, once you get that down there a little bit, just double click that box and it'll go all the way down for you. All the way down, right? I usually try to follow it, Command Shift down. I wanna make sure it didn't go too far. Yep, it's good. I'm gonna have a problem with this last guy I'm gonna see already because he's got no weight listed. But we'll figure that out later. Okay, everybody, now you just computed the weight in kilograms for every player. You converted, right? 2,875 players' weights from pounds to kilograms. Congratulations. That would have taken you a long time to do with this, right? Spreadsheets are awesome. Let's do something else. So we want to do BMI, but that's, we needed two things for BMI, didn't we? We needed height and we needed weight. We needed height in meters. Oh boy, this is going to be a headache because what is height in right now? It's feet with a little line and then inches with two quotes, right? Oh boy, this is going to be a mess. How do I turn this number into height in meters? Well, I can go if I wanted to, okay, to Google and say convert inches to meters, and it'll tell me I just need to multiply, by 0.0254, right, to convert 1 inch to a meter. Is it meters, by the way? Let me double check that. Yep, height in meters. All right, 0.0254, that's cool. But the problem is, how do I get this in inches? Because right now it's in feet and inches, isn't it? Feet and in inches, see what I mean? So I need to break this one up. This is gonna get a little tricky. Highlight all of E, the entire thing, okay? Hit Control-C, you're copying the entire column E. I'm gonna leave it as is because I don't wanna touch it, but I wanna move it over here to the right in L, and I'm gonna put Control-V to paste it. So Control-C to copy the whole thing, Control-V to paste the whole thing. I wanna start working with this data. Now I'm kind of in this, from that, remember our process flow, where am I? I'm sort of in the preparing the data, aren't I? I wanted to compute BMI, but I couldn't because I didn't have the data values in the right units. I need to do some work to get them there. So here's what we're gonna do. This is a really interesting trick that's super powerful once you learn it. It's called text to columns. I need to break this up into two columns. I would love to have it like this, 5 feet and 8 inches in two separate columns, right? This is what I wanna get to. Don't do this, but I just wanna show you what I wanna get to. Not inches, inches. Okay, so that's what I wanna get. But it's gonna take me a long time to type it all in. So, but what's awesome is Excel can just do it for you. Let me show you how. It's called text to columns, okay? Go over here, click all of L, the whole column L. You click the whole thing. So the whole thing's highlighted. See this little icon right here in the data tab? Click on the data menu. It's right between formulas and review up in the top. You should have something called text to columns. You see that? Click on text to columns. What is this doing? This is saying I would like to break up my data. So it opens up a little wizard and it says, oh, your data is delimited. How would you like to break it up? I want to say delimited based on characters, right? I want to break it up based on these quote characters. I want to slice it up, okay? It isn't a fixed width like a tab or a space. It's like, no, it's actually based on that little character, right? So I want to choose delimited. Go to next. Okay, now tell Excel, uncheck tab. I want to check it on other. Let's first break off the feet from the inches. So I'll put 1 quote in there. See that little value there, the 1 quote, the single quotation mark? I check the box for other. I use the quote. Now what Excel is going to do is it's going to go down every single cell and it's going to look for that little single quote mark. And it's going to break up everything on the left of it and everything on the right of it. And those are going to go in different cells. Okay, then I'm going to say next. I'm not going to worry about this. General format, that's fine. And I'll hit finish. Oh, what a mess. I hate when it does that. Let's undo this. So it's thinking it's a date. So that's a problem. That's a problem. We don't like that. We don't like that. Why did it do that? So it should just say 5 here, but instead it gave me a crazy date because I think it's interpreting it in the wrong way. Okay, I got to do something even more to get my 5 in there. What a pain. Watch this. No, then my zeros are all going to be, yeah, I can do it. I can do it. All right, so first things first, let's get rid of this quote mark, okay? So highlight all of M and go to text to columns again one more time. I want to get rid of the double quote. So go to text to columns one more time in M with the inches with the quote, okay? Delimited, same thing, go to next, okay? And now instead of the single quote, we want to break it up based on the double quote. So hit shift and hold the double quotes. And then say, go right to finish, that's okay. All right, so this is my number of inches. That is fine. Everybody with me? You should have, did you have the same thing as I got? Like a 1-5, like a date in this one? Oops, sorry. I got a date right here, didn't I? That's trouble. Why did it do that?
Mine came out with.
You have a 5?
Yeah.
Awesome. Everybody else have more, what Maureen has, a 5 right here? Mine tried to make it a date, which is such a pain. All right, if yours did what I did by making it a date, I have to be stubborn. I'm going to say, okay, fine. I'm going to say equals day, right? And hold the parentheses. I'm making a function here, equals day, and I check this guy, L2, and I close the parentheses. Let me just make sure it works. Yeah, okay. So
Ben, I just converted that to a number before I
you can just convert it to a number? Let me just see.
Yeah.
Okay, so you just go to format cells. Let's see, home. Thank you, guys. Yeah, hit a comma. Ah, you're awesome. I was going to pick the day out of the date, which is kind of bizarre that it made it a date. It was like a formatting thing. So thank you. I hit all of L, and where it said 1/5/1900, okay, I went to this little number right here, okay, in the home menu, and I hit the comma, which means change the format to being a number. Now it's 5.00, so I can hold down L again, and see these two icons right here, increase the zeros or decrease the zeros? I can just hit the arrow to the right, which is saying decrease the decimals. I'll hit it twice, and it just gets rid of those 5s. Everybody with me? Anybody have any problems or issues that they need me to redo something? Okay, now the thing about it is, this is like a process, right? This is the and I think this is what we were talking about before. Dealing with dirty data can be such a pain. I try to think of it as a puzzle, okay? And my puzzle, I'm trying to get the number of inches. I just want Excel to tell me how many inches every player is in height. Well, I took all this time to get it out of this ugly format of inches, but it's super common, right? We see this all the time. So I broke it up using text to columns. I have the height and the inches, but I still just want total inches, right? I'm going to say height in inches. I'm still working here, right? Unbelievable. Height in inches. I'm still not there. I'm going to get there right now. Height in inches. Well, it's just equal to 5. That's the number of feet times 12, right? There's 12 inches to a foot. So L2 times 12 plus M2, right? So this player right here is 68 inches. Thank you. 5'8" is 68 inches. Right? And then just like I did before, I can click in the arrow in the bottom, not the arrow, the little box in the bottom of that cell. Now, because it's a formula, right? So I can click on it and double click it, and it gives me the height in inches of all my players. With me? Go all the way down, check it out. I got the height in inches of every player. Awesome. Okay, but, oh, remember, I didn't want it in inches, actually. I wanted it height in meters. Height in meters. I got to work still. Okay, well, I'm going to take their height in inches, multiply it by what? 0.0254. That's 1 inch in meters. Okay, N2 times 0.0254, enter. 1.73. Okay, double click again the box to compute that same formula for all the players. Oh my gosh, I'm finally almost there. I got my weight in kilograms. I had to spend all this time breaking up the height in inches and bringing it back together again and then converting it from there, right? Now I can do BMI, right? BMI, body mass index for my players. If I'm a dietitian or a trainer or a physician, this is maybe something I'm doing, right? Because I care about the condition of these players, right? So I'm going to say equals, what was the formula again? Let's look at it. It was the weight in kilograms divided by the height in meters to the second power. Okay, how do we do that? Well, let's take, first of all, the weight in kilograms. That's just K2. And I'm going to divide that, so it's a slash, right? Divide that by, I usually like to use parentheses. In this case, you technically don't need to, but you have to really know order of operations. So I'm going to put an open bracket, height in meters, okay? Now you can do it two ways. I could just say asterisk O2 again, so I multiply it twice, that's squaring it, right? O2 times O2, right? Meters, height in meters times height in meters. Or instead I could do a little caret, O2, right? Height in meters, caret 2 to the raised to the second power. So I'm taking my weight in kilograms, dividing it by the height in meters. Oh, I spelled that wrong. Height in meters to the second power, close the parentheses, right? So I can look at it like that. K2 slash parentheses, O2 squared, close the parentheses, enter. The BMI for this player is 24.33, okay? Same thing, double click, boom. Now I know the BMIs for all the players in the entire league just like that. This is not big data. In a couple of weeks, we're gonna be dealing with hundreds of thousands of records and doing math on that. But this is pretty big, you know? It's 2,800 records. It's certainly more than I can do by hand. I mean, unless I want to lose my whole day and maybe go a little batty and need to increase my glasses prescription when I'm done. But the point is I'm able to compute the BMI for everybody. Get caught up on that, or did y'all follow me? Yes. Okay, one more fancy thing I want to think about. Conditional formatting. If you highlight P, column P, and you go to conditional formatting, it's in the home menu, home, conditional formatting. See that? We'll do our first data visualization. Click on conditional formatting and say data bars. And then say, you know, yeah, sure, the blue gradient fill, that's fine. Okay, check it out. You just made a bar chart. I love how Excel does this actually. It's super quick. I can see right away and scan and see, you know, instead of just looking at the numbers now, right? I'm able to look and find the bars that are the highest. I see the players that I might be concerned about, right? The ones with the higher BMIs that are maybe overweight. You just made a bar chart. You put it right there in the column. It's pretty cool. Now let's say, and then we're gonna wrap it up and then call it a day, but let's say, okay, it turns out that according to medical professionals, if your BMI is less than 18.5, you're underweight. If your BMI is, and this is why some people hate it, because it gets into all kinds of body image types of conversations, right? So I don't know. I'm not a believer in BMI. I'm just saying I would love to go through the exercise of determining, okay, from a BMI point of view, which of the players are overweight. Well, those would be players. Let's do it simple. Let's just do it simple. I could get really granular and figure out exactly which category you're in. Now, what that's doing is it's taking a continuous variable, BMI. We know that's continuous, right? How do we know it's continuous? Look at the numbers. Look how granular they are, right? You can keep getting finer and finer. So, and I want to turn that into a category. In other words, people with a certain grouping of BMIs have a certain category name, which would then be ordinal, right? Because it goes in an order, and players who are underweight would be, you know, in a certain order, and then it would go to healthy weight, and then it would go increase to overweight. So you're taking this granular thing, BMI, and you're chunking it up into this ordinal qualitative variable, right? By grouping it. But since we're out of time, I'll do something very simple, okay? And I'm just gonna say over here in Q, I'm gonna say overweight, question mark. Right, so I wanna know which players have a BMI higher than 25. Because I can see right away that if they're from 25 to 29.9, they're overweight, and 30 or higher would be obese. So I guess I maybe should call this overweight or obese to be technically correct, right? I just want to know players that are either are you or are you not overweight or obese. Okay, so I'm going to say equals. Now I want to do this is a cool little thing Excel lets you do. I want to create a criteria, so I say if, right? Type the word if and do open parentheses. What do I want to know? Well, if this cell right here, this value, right? If this value, click that value, if P2 is greater than 25. In fact, I think I maybe need to do greater than or equal to, don't I? Yes. So if it's 25, you're categorized as overweight. So I technically want to say greater than, which is a caret to the right, and then equal. So if P2 is greater than or equal to the value 25, okay? See this little help down here? It's telling me, it's saying, oh, okay, if, what's your test, Ben? If, well, my test is the value P2 greater than or equal to 25? Then I do a comma. It says, okay, what do you do if true? What do you say if it's true? Quote, yes, end quote, right? So if that number is greater than or equal to 25, hey, Excel, I want you to type in this cell the word yes. And then I put another comma, and it says, okay, well, what do you want me to do if it's false? In other words, if the value is less than 25, then I would say, type in there, no, and quote, and another quote. And then put a right bracket there to close off the if statement. Let's review. If lets you take a look at a cell, do a test, is it greater than or equal to 25, and then tell Excel what to put in there if it's true, and then tell Excel what to put in there if it's false. And then I hit enter, and it tells me this first one, well, oh, that's no. You know, this person has a BMI of 24.33, so no. But if I double click and it goes down, now I can see that there are some players that, yes, actually, like for example, this player right here, 25.09, just barely, right? And I could go in just like before, and if I go back to data and click on filter and turn it off and turn it on again, and then we'll wrap it up now because we're out of time, and I want to be respectful for your time. And the down arrow right here, I could just look at all the players that were overweight or obese. There we go. How many of them are there? You know, well, I can see right away that it tells me there are, let's see, how many records are there? That doesn't make sense. Yeah, oh, there are a lot. Is that right? Am I looking at it right? 2,700 of the 2,800? Wow, really? Almost all of them. Huh. Yeah, I guess almost every NFL, well, they're big players. What can I say? And this is why, again, this is why it's sort of that, because you know, some of them are just not necessarily, you know, fat in the sense of they're large, they're big guys. So technically from a BMI point of view, this is why people get wrapped around the axle. Anyway, this is not a conversation about the merits or lack thereof of BMI. It's essentially saying, check what you guys just be able to do. You took a 2,800 row data set, okay? You did a bunch of hoops and gyrations to be able to compute this BMI value. Then you try to check the value for whether or not they're overweight or not. And then you filtered it, and you got to the point where you could figure that out, okay? We can edit it. Let's go back and uncheck the filter. Let's say, you know what? I'm going to go back to this filter. I'm going to say select all one more time. Let's say, wow, there's so many of them. Let's just check if they're obese. Let's undo all this. I'm going to delete it, okay? And in here, I only want to know if they are over 30 or more, okay? So I'll go in here now, and I can just go in and edit this number. Instead of 25, I'll say greater than or equal to 30, and I'll say enter, okay? And then I'll double click on that one, and it'll change them all for me. Thank you, okay? And now I can filter and see only the players that are categorized as obese, and there we go. There they are, right? So those are the ones we're having a different kind of conversation with potentially. All right, we're out of time, but this was awesome. Thank you guys so much. We did not have time to do pivot charts today, so we will do that first thing on Thursday. That is something you do not want to miss. That's a very, very important part of this class, so I'm going to make sure we get to it. But we kind of covered some ground here. You know, we were able to kind of get our hands dirty on a data set and start to answer some of these questions, okay, and figure them out and start to even do some preparation and some analysis, even some basic visualizations without ever leaving Excel. You know, Excel's, like I said, this is one of the most powerful software tools ever written. It really is incredible and amazing. And I think it's something that we all should know how to do. We'll play more with it. We're not going to leave Excel. We're going to continue to play with it. And we'll do, like I said, we'll come back and finish off this pivot table one at the end here. I want you guys to spend a little bit of time playing around with this. Now, your homework session, if you choose, and I highly recommend you choose to follow it and take the challenge here, is to go find a data set of your own, one that is about a topic you're interested in, okay? And I want you to just go through this, think about this process here, right? What's a question you have? Formulate a hypothesis, open that data set in Excel to sort, filter, or make a pivot table. I think you can, if you go in and make an account on data.worlds like I did, right? And you go to the home page here, it's just gonna show you, well, hey, Ben, where the heck do I go to find data? Okay, well, let's do that. Someone give me a topic they're interested in, any topic. Something that go ahead.
Scuba diving.
Scuba diving. Scuba diving. Okay, let's see. We got some data sets on scuba diving here. Diving deeper. Companies worked at. Boats. Ooh, this is a tough one. This one's not, it's not turned up some great stuff here, is it? I don't see a lot of awesome scuba diving data sets in here. Scuba Girl, Scuba Gem. Looks like people are using that name a lot. Huh. Sea habitats. I might find some interesting things there. I don't know. I'm not quite sure. I'm not sure if I do. Let's try another one. Anybody have a suggestion?
Live music.
Live music. Okay, we can look at Nirvana live performances, ZZ Top's discography, so all their albums, I suppose. So people have entire folders for music, maybe. Or maybe I want to go up here and change live music to concerts, right? So I go in there and find Coachella Twitter, maybe. That's interesting. Cultural arts, ticketed events. So I might start to explore some of these, okay? So try, use data.world if you want to, see if you can find an interesting data set. And again, what you can do is, I think you can do, they should do a filter by type, but we'll see. Right on. Okay, we are out of time. So next week, just so you know, what are we doing next week besides going back and finishing up the pivot table stuff? We're going to do a really cool thing called VLOOKUP to talk about how to combine two tables together. And then, oh my gosh, we're going to do SQL. We're going to do SQL. We're going to write queries in SQL live in the class. You've heard of it. This is like this other world for you. It's not exactly my forte. We're going to write SQL queries together, okay? And you're going to know by the time we're done how that works, a little bit about it anyway, okay? And then I'm going to show you this magical tool called Tableau Prep. I'm telling you, this is the part where I'm just like actually excited about cleaning dirty data. It's a beautiful tool. I don't work for the company, so I can say that. And it has nothing to do with me trying to promote their software. I love Tableau Prep, and I'm going to show you how to use it to play around with some data, clean dirty data sets, and get us out of dirty data purgatory and into some analysis really quickly. And the purpose of SQL is frankly, to show you the hard way. And I think it's valuable to know it. But the good news is a lot of times you don't need it unless you're doing DBA or data engineering work. In which case you absolutely need it. You're going to live in it. So it's kind of like this divide of the back end and the front end. Back end people use SQL left and right. Front end people kind of depend on those people to use it to give them great data, in which case they analyze it. All right, I use a little bit more of your time than I told you I would, so I apologize. We are going to be closer to the end time next time, okay? And I'm gonna have to hustle to get through the pivot stuff. So anybody have any questions or comments? By the way, shoot me a note at bjones@dataliteracy.com. Big part of me and value for me, other than meeting you all and thanking you for all your service over the years, is you all telling me how this is going. Okay, so feel free to email me your comments and thoughts. You don't need to say it now. Let me know what you thought, and let me know what I could have done better. Let me know what was confusing or hard. Maybe the parts in the session where you got caught up. I'm gonna take good notes on that and make sure that I fine tune things for going forward. Okay, everyone, thank you. I got to race to dinner with my girlfriend. Oh my gosh, I got to go like way across town with some friends. So I'm gonna drive safe. Everybody, thank you. Great to meet you all. Hope it was valuable for you. And you all have a great rest of your day and evening. And I will see you Thursday, 3 o'clock, okay?
Yes, thank you.
All right, bye, everyone.
Nice to meet you guys. Take care. Have a good night.
Okay. Bye-bye,
All right,
everybody.
you too. Bye, everybody. Awesome stuff. Thanks.